Good morning, everyone. It's really nice to see you. Really sorry for the delay. We just wanted to let as many people in as possible, and I know we had a few delays with checking the COVID side. But thank you all for making it here. Thank you all for abiding to all the rules that we've set out. This is now the 34th year of the National Student Space Conference. Throughout 34 years in the running, we've been providing opportunities to students all across the UK space sector, from disciplines from all backgrounds, a chance to learn more and to meet people like in this room. My name's Antonio. I'm the chair of UKSEDS for this year, up until tomorrow. Someone else will be replacing me. It's probably an obligatory nice to see you in the flesh as well. The last conference in person was 2 years ago in Birmingham. It was just before the pandemic. A year later, we all went into lockdown, and I don't think any of us expected it to take almost 2 years to be back like this. I know we're not quite fully back to normal, but we're proud to actually be in person with you guys again. Over the last year alone, advancements in the sector have been incredibly inspirational, from increased goals towards working towards a more sustainable future, to the James Webb Telescope, talk of which we'll have one tomorrow. All the work from students and professionals alike has been incredibly commendable. And this conference is a chance to learn about it all. We've got speakers and panels from all the current topics. We have companies where you can learn from all the opportunities that are coming up in the space sector, and a chance to meet other people like yourselves. Before we start, a couple of housekeeping rules. There's no fire drills, so if you do hear a fire alarm, please follow our kind volunteers out towards the exits. There are also fire exits which are marked all across the building. There are 2 streams. So stream number 1 is going to be in here. Stream number 2 is across the lecture theatre. Across the road to lecture theatre number 2. There are going to be volunteers at both doors to guide you, so no worries about any of that. Please, if you haven't familiarized yourselves already, there is a code of conduct and a COVID policy that we'd ask everyone to abide to. I know the restrictions, at least by the government, have eased down, but we want to make sure that everyone is as comfortable as possible with everything that's going on here. So please follow them. We ask everyone to wear the masks unless you're presenting, or unless you're eating, drinking, or exempt, of course. Some attendees are also still a little bit conscious of large gatherings, so please be mindful of that. That's what the colour wristbands are for. Green means you're happy to talk, you're quite up close, you're happy to do handshakes, you're happy to have contact. Yellow, you're happy to be quite close but no contact. And purple, please social distance from those people. All of this can also be found in the program in case you forget, similarly with colours for the lanyards, which I'll explain in a second. Volunteers, all the volunteers are wearing red lanyards, and you'll find us with some t-shirts that say "Ask me about space." So please ask us anything you need. There's an info desk just outside the door as well if you need any support. We got our sponsors and our speakers with black lanyards, and you got yourselves as delegates with white lanyards. With that in mind, I have to give a massive thank you to all the people from UKSEDS and all the people from KCL Space Society who could not, without whom this could not have happened. Similarly, the speakers who have so kindly supported everything that we do, they're all around. Please speak to them. They have some great opportunities to talk to you guys about, and we couldn't have made it without them. There's going to be photos and filming throughout the day. If you don't want to be a part of that, there's a camera right there as well. If you don't want to be a part of that, please let us know. We'll give you some reflective tape, and we'll make sure that photos are not taken of you or that you're cropped out of anything like that, especially if they are to go online. These streams are also streamed. I suppose I should say the lectures are also streamed. You can watch them online later. You can find them on our YouTube channel if you want to rewatch anything or if you missed anything, because they're also streamed, so you can't watch everything at once. There are 2 of the talks that won't be streamed, however, and recorded. There is one tomorrow from Rory Holmes, and there is the Fistral workshop tomorrow afternoon. Please come to the Fistral workshop. It's going to be incredible. Similarly, come to the AGM. Lots of people leave before the AGM, but that's where the fun happens. We also have a reception tonight, by the way. I hope to see you all there, and a social. There's a very busy weekend ahead, so please make the most of it. I'm sure you all want to pack in as much as you can to every second, but please also take care of yourselves. There's breaks throughout the day. There's lunch. Please eat and drink as much as you can. We have a recreational room, and we have a breakout room if you want to take some time in between to meet others, or if you just want the choir room to just be by yourselves for a little bit. Sometimes you might need to do a little bit of work. Sometimes you need to break away from things. This goes out to everyone in the audience. The passion and determination that each person in this room has not only makes this conference possible, but also everything that goes on in the space sector and the growth of the UK sector as a whole. So I want to thank every single one of you for everything that you do and for being here. And with that in mind, I also want to pass it on to Paul Bate, who has a very similar message, who unfortunately couldn't be here because he has to go to somewhere else, but he's been very kind to send us a pre-recorded message.
Me to join you at the National Student Space Conference today. I'm sorry I can't be here with you in person, but I hope you have a brilliant weekend. Thank you for inviting me to join you at the National Student Space Conference today. I'm sorry I can't be here with you in person, but I hope you have a brilliant weekend. I'm here to talk about why it's so important that we bring more people right across the UK and beyond into the space sector. But before I do that, let me make the case for space. Because not everyone recognises just how important space is to our way of life. Today, our financial markets wouldn't work without the precision timing data that comes down from satellites. We certainly wouldn't be able to monitor and mitigate the results of the climate crisis without being able to look at them from above and go right through, for example, the forest canopy and see just how much biodiversity loss there is in our equatorial forests. We wouldn't know what the weather is going to be. We wouldn't know if there were major flares, coronal mass ejections coming out that are going to affect our critical national infrastructure. Looking forward, we're certainly not going to have autonomous cars without having the satellite navigation and artificial intelligence behind it. Throughout our lives already, we are dependent on space, and that means we're going to be dependent on yourselves. There are already 40,000 people working across the space sector in the UK alone. That figure needs to grow to over 70,000, and I hope as many of you as possible will be part of that journey. That's just out to 2030. I haven't even talked about the basic discovery science, the fundamental understanding of our universe that comes from being able to look out into space. Millions, perhaps billions of people around the planet were inspired over the last 20, 25 years by the Hubble images. And on Christmas Day, we launched the successor to Hubble, the Webb telescope. It was a global effort. NASA, the European Space Agency, the UK playing more than its part. There are 4 instruments on that telescope platform. One of them co-designed, built and scientifically led right here in the UK. Colleagues up in Edinburgh led by Gillian Wright. So right across the spectrum of space, there is so much to be done. And although if you want to be an astronaut, that's amazing, there is in reality 1,001 different jobs to do in space. Almost every profession is needed in the space sector. Whether your thing is about design, engineering, then we need you. We need you to help build and create those satellites, launchers. If your thing is about the fundamental physics and the science, then we absolutely need you in space science and astronomy, astrophysics. If yours is an ability to do software engineering, then of course that's absolutely intrinsic. But if you're great on the business side, if you're commercial, if you're entrepreneurial, if you get on really well with people and can help teams to create so much more than they could do individually, every one of those skills is valuable. And the truth is, it isn't just the building stuff and getting it up into space. It's the power of the data that comes back down. So it's the applications development, it's the interpretation of the data. It's such a wide sector. And I really hope that you want and continue to want to join it. The courses that you're already doing are a big part of building your own skills, of course. But to go a stage further, I know that employers always look for that bit extra. So whether it's an internship or an apprenticeship, that ability to demonstrate that you are passionate at learning on as you go is really important to get in those early jobs. And the UK Space Agency funds things like the Space Interns Programme. There are also lots of competitions, ways to get involved from the nanosat competition or Satellite, ways to design small satellites. UKSEDS has a rocketry competition. All of these are great ways to show your teamwork, show your design skills, show that you are truly going to be part of the UK space team going forward. And that's what I really hope you get out of this conversation and your conversations right throughout the conference. So once again, I hope you have a wonderful time and thanks for listening.
there's two things I want to quickly reiterate from Paul's speech. One of them being the variety of opportunities across the space sector. But especially before, it used to be thought that engineering or science are the main opportunities in the space sector. The conference this weekend in itself reflects that is just not the case. From the broad opportunities that the sponsor are providing to the broad types of talks, you can find anything you want in the space sector. So please, 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 if you think that space is not for you, I suppose you wouldn't be here, but if that's even crossed your mind.
In Stevenage.
Interrupted. If that even crosses your mind, I hope this weekend stops that doubt. The other thing I really want to add is, like Paul said, the passion to get into the space sector is really what matters most. This conference alone has been put together by volunteers in their spare time, outside of jobs, outside of university. Everything you see today has been done in a couple of months from people who have about 3 hours spare a day. With that in mind, I hope you guys have all a wonderful conference. Please just join me in thanking all our speakers and sponsors and all the people who have made this possible. And see you around.
Hello. Hello, hello. Hey, nice, there we go. Hello, everyone. We're now going to get underway with Benchmark Space Systems. But first of all, I want to make you aware that over in Stream 2 on the other side of the road will be the Airbus competition presentations. So if you're interested in checking that out, make sure to head across to Stream 2. Benchmark Space Systems provides safe and capable propulsion systems for spacecraft ranging from 3U CubeSats to ESPA class. Mark is the company's Director of European Operations, utilising many years of experience across the space sector to manage engagement across the continent. Mark's talk will be taking a look at the importance of propulsion systems and their role in the sustainable end-of-life practices. On to you, Mark.
Yeah. Good to go. Good morning. I'll just take a minute to say it's good to see so many people here. So, It's been a while since a lot of us have been out and been at conferences and been able to speak face to face. Too quiet? Can everybody hear me at the back? Is that better? Can we all hear? Yeah? Yeah, perfect. Okay. So thanks very much. It's fantastic to be able to be here in person, be able to speak to you and see you face to face. I'm glad to be here to be talking to you. I hope this won't take 10 minutes because I don't think I've written 10 minutes worth of a speech. But we'll start with a quick poll of hands. So just who here is building a satellite, involved in building a mission, now or in the next couple of years? Okay. Who here drives an electric car or a hybrid vehicle? Anyone? 1, 2, 3, 4, wow, okay. Who rides a bike instead of driving a car? Oh, there you go, so we've got our audience. Okay, who eats a plant-based diet? Okay, and who sometimes eats a plant-based diet? Ah, look at that, there you go. Great. Well, I'll tell you who I am, and then I'll answer some of those questions about myself. As you can see, I'm a business manager. I'm a certain age. I'm pretty much what you would expect. I'm a middle-aged man. I'm choosing my next car. I'm keen to get a hybrid or something all-electric. I'm on a green tariff for energy at home. You know, I've started to eat a plant-based diet more often, and as a family, we're cutting down on meat. We're trying to shop locally, you know. And if Scotland had the climate for avocados, then I think, you know, my green credentials would be far greater than they are today. Because of my avocado habit, this year, you know, as a New Year's resolution, I decided not to buy any new clothes. So if you're at any more space conferences this year, you'll pick me out quite quickly because I will be wearing this. So what does that have to do with space? What does that have to do with all of us? So what I'm going to tell you is my experience of space, why I'm here today, and what these issues are really all about. My first mission in space was at UKSEDS in Darmstadt in Germany. I was involved in the Meteosat program of Earth observation satellites. I went on to work on MSG-1, MSG-2, and helped bring them to space and commission them in orbit. They're big satellites, you know, they're huge. They're probably the size of a Mini. They weigh tons. They cost, you know, hundreds of millions of euros to build, design, develop, and deliver. They go to GEO, so they have an apogee boost motor. When they get up there, they're spinners, so they have reaction control systems for propulsion and for station keeping. And maneuvers on these satellites are big events, you know. You spend time in the simulator beforehand getting trained. If there are any anomalies, you're able to react to them. The control room is buzzing when they come around. People are in there, engineers are in there, analysis, everybody's there, you know. And to be honest, it's one of those operations that when you're involved in it, you feel the pressure, but you feel like you're actually flying a satellite. It's fantastic. Who doesn't want to feel that? For me, fast forward 15 years. I'm working in CubeSats, 3U, 6U. They're in a LEO orbit. They cost probably less than £1 million all up. Magnetorquers and reaction wheels for control. Very few of them actually carry propulsion. And what have we seen? We've seen the emergence of the new space market. Suppliers and operators are bringing hundreds of satellites to orbit, and they're achieving missions that previously were only within the reach of governments or military agencies. The democratization of space has taken us beyond what most of us would have envisaged 20 years ago. But we've seen the downsides to this, you know. It's not all good. Debris, congestion, these things are being talked about on a daily basis. Leaving your products in space for 25 years after it's completed its primary mission, it probably doesn't feel as sustainable as it used to do. Maybe 10 years ago, not even 5 years ago. So, what does that mean for us? It doesn't really look good if we keep doing this. If we consider the number of companies investing in constellations and satellites, we can see that billions of dollars are being added to the valuation of constellations and companies that are delivering them. The numbers of the satellites in these constellations, once unimaginable, probably now some of them running into thousands. So, what I want to tell you all, well, the talk is called Why Take Tanks? And it's as easy as this. We now have the ability to get to orbits easily, OTVs. You can take a 3U to GEO, probably sometime next year. And with that, you can be operating 10, 15, 20 years on something that we used to chuck out of the International Space Station, would degrade and burn up probably within 3 years. So what are we doing about this congestion? Well, propulsion suppliers and companies clearly are pushing for regulation. They're pushing for legal requirements to deorbit quickly and effectively. You know, we do this because you need propulsion for that, and we'll sell it to you. But the thing that we need to understand is the likelihood of a ruling from any government that makes taking propulsion compulsory, making a deorbit capability something that happens within months, weeks, rather than years, is probably some way away for all nations. Governments don't like to legislate. And these sorts of changes are taking their time to work through international space law, which really is an emerging landscape. But perhaps real change happens the same way my move towards a greener, more sustainable way of living has. Let's be honest, I did it because it was easy. I did it because it was part of the system that I live within. I got to be driven about in a Tesla. They are fast. They are incredibly fast, you know. There's hardly any tax on them. They look quite nice. My energy supplier did a green deal. It was cheap. I bought it. I didn't even think about it. My wife told me I need to eat less red meat. And my local supermarket does veggie doner kebabs. What can I tell you? So, I'm asking you, you're the leaders of our industry for the next 20 or 30 years. Make it easy for your missions to take propulsion. Make it easy for them to leave orbits clean and sustainable. Think of the end of your mission not as being the achievement of your objective, not of imaging the Earth, communicating on the moon, sending 5G to somebody in a desert. Think of it as being what happens after that objective. So, as the talk's title, take some tanks, take some propulsion, you know, bring your satellites back to Earth, and if you possibly can recover them, reuse them, then do that. Make their impact on the space less destructive than it might be today. Let's not try and leave products up there for 25 years. Now, let's be honest, I don't mind if you take my propulsion. I prefer it if you took my propulsion. But in reality, I just prefer it if you took anything. Because changing the mindset and seeing the need helps us all change. So, that's an emotional plea from me. But everybody here is probably a scientist, an engineer, or going to be involved in that arena somewhere, and we're pragmatists, really. So it comes down to money, it comes down to cost and time. So what am I really telling you? Well, I know that every mission or satellite being designed in the next 3 to 5 years, every craft that goes into space won't have propulsion on it, and it won't have a deorbit capability. But perhaps some of you here today will go back. Perhaps you'll make some of those easy changes in your work life that I made in my personal life. That makes the start. We think about a shared responsibility. Perhaps you'll take a small passive deorbit device. Perhaps you'll take some propulsion. Perhaps you'll take electrical or chemical. Whatever you do, leave some total impulse for the end of the mission. Take the satellite out. Clean up behind you. And if in the coming days you decide you want to do this with some great propulsion products from Benchmark, then you'll know where to find me. You'll recognize me because I'll be wearing the same clothes and I'll probably be driving a Tesla. Thank you.
young graduate trainee. At ESA, Maria was a core member of Young ESA and a founding member of the Young Professional Advisory Group. Maria is now the sponsorships co-lead for the Space Generation Advisory Council and is working on a new internal initiative for young professionals within DLR. Maria's talk will give an overview of performing science on board the ISS and how uncertainties are handled in this environment. Maria, over to you.
Good morning, everyone. Can you hear me okay? Is that fine? Perfect. So I'm happy to talk. As I said, I'm Maria. I'm working for the German Aerospace Agency. I'm also happy to talk to you afterwards about my space journey that Josh just basically told you a bit about. And now I'm going to introduce you into the International Space Station operation, and we're going to focus on the European aspect of it, and in particular, how we're doing payload operations. And so the agenda, I'm going to give you a short overview about the International Space Station, which I think is very important for you to all know, because it's one of the greatest achievements of humankind, about the operations, as well as an overview where I'm working, the Microgravity User Support Center. We love abbreviations, so we call it MUSC, and also then about the ISS planning. How do we actually go from the first idea of the scientist to the operation of this experiment then in space? And also, how do we communicate? As a flight controller, communication is key. I would like to introduce you to that, as it's a very particular way we are doing this on the space station. Then I'm gonna give you a short overview of the next upcoming experiment, Suture in Space, that we are gonna run in June this year, hopefully. So, and then I want to end up with the kind of uncertainties that you see in space and that are also part of our everyday life. So I would like to start. I don't have a clicker, unfortunately, so I have to stand somewhere here. With the space station, so as you see, this photo is like just giving you an impression about how big the space station is. It's actually a bit of an older one, because you're going to see ATV on the bottom, which we do not have anymore. So it was a European automatic transfer vehicle that was giving payloads and also kind of supplies to the International Space Station. As you see, we have 16 really big solar panels, and only basically the middle part is the one that is pressurized, and the rest is basically the thrusts, you can see, and these are the radiators to get rid of any excessive heat. So you see, nothing comes as normal, so you have to bring everything there, and even now the life support system, for example, is not closed at the moment, so the ISS still relies on supply missions from time to time. So here you have some key factors. So since 24 years, we have the ISS built up. So the first module was put in space 1998. And then already 2 years later, we have the first human beings living and working in space. So it's been like 22 years now that we constantly have astronauts on board the space station living and working there together. It is an international collaboration with 15 countries, and it's been peaceful up to now, so we hope that it continues like that at the moment. And as it is, as we always say, it's a human, the biggest achievement of humankind. So the thrust length is 108 meters. So if I would be in America, it's around a football field if you would put down the ISS. That's how big it is. And 73 meters of the solar area length. It's the speed of 28,000 kilometers that is surrounding our Earth, so every 90 minutes it has been once around the world. The altitude is around 350 to 400 kilometers. So right now we have two ways of getting there. The fast track is around 6 hours, that actually the astronauts could be from ground all the way to the space station. The normal way took around like 2 days. It depends also on the launch window and where they're launching from. So yeah, then we always see what my speaker said before. We're also seeing changes in the ISS right now. So after the Space Shuttle program finished in 2011, where we also see the ISS was made complete, we have now more shift towards commercialization. And last year we have our first commercial crew, and we already have Crew 2 on board, and we're going to have the launch in April of Crew 3. But we are going to focus today on the European module, which is called Columbus. And you see here a nice photo from it from the outside doing an EVA, extravehicular activity. But of course, the ISS is more than that. So you see here an overview picture on your right, on your left, on your left. And we are basically separating the space station in two parts. One is the Russian segment, and the other one, we call it USOS, is the American/international partners part. So you're gonna basically see this is the Russian part. You see here the red part is docking possibilities, and you see where Soyuzes could be docked. Here this is then the connection, and all of this is the USOS part. The X actually are marking the payloads that we are operating at Mosk, so that we are also going to focusing for today. And you see here the USCV, so this is like the new commercial vehicles and where they can be docked on board the station. The blue ones is for berthing, so berthing means we are using the Canadian robotic arm that are then flying in kind of like a virtual box that will be grabbed, and then they will be docked to the space station, and we use them mainly for supply missions that are going to have these blue docking ports. So then this is all the international operations teams. We actually have 6 main of them across the world. The RMCC is the only one I'm not going to take you into more detail. That is the Robotic Center in Canada. So any kind of operations of the robotic arms will be then also supported and monitored from there. For the rest, I'm going to give you a brief overview. So we have Houston. They are very important as basically the ISS flight is there. ISS flight is basically the head of the whole space station. There, he or she is responsible then for the whole safety of the International Space Station, the crew and the vehicle. And also kind of like resources are be planned there. So how much power do we have? How much water cooling? Can we actually perform all the experiments on that day? Because we have to monitor closely all our resources and plan it. So planning and documentation is very important for the whole ISS project. Then we have the pendant to it is in Moscow. So basically the Russians are operating everything from there, and especially from the European perspective, we don't have so much to do with them. Then we have Haswell, so basically the payload center for all the NASA experiments is located in one location in Huntsville, Alabama. We call it POIC, so Payload Operation Integration Center. We are closely working together with them, especially in my control center, as we are having one payload that is integrated into a NASA REC. So we are having close contact with them, and it's very interesting as they actually are 8 hours behind. So whenever we finish our day, they are just starting. So it's very interesting how everything is still working with all these conditions. Then also the Japanese module, we call it Kibo. It's in the control center of it in Tsukuba in Japan. Then the main one we are focusing also on today is actually located in Oberpfaffenhofen. But if you maybe are not a native speaker of German, we decided to call it then Munich, so it's a bit easier for everyone. So whenever you hear then space to ground, they will call Munich and not Oberpfaffenhofen. I think it makes it a bit easier. I mean, you can all give it a try later. Yes, so they are basically sitting there doing all the systems integration, and also the call flight, basically our pendant of ISS flight, who is responsible for the safety of the Columbus modules, is located there, and we have a very close collaboration with them for the payload centers. So, and one specialty for Europe, we actually have user support centers. So NASA had only one, Alabama. We actually have now like 4 main ones distributed across Europe. So we have one in Switzerland, one in Belgium, one in France, and one in Germany. And my control center I'm working for is the one in Germany. You see photo there, me on the biolab console, like we currently had just an experiment with Matjaz, the European astronaut. So, but what does the Mosk do? So we basically are planning and testing and preparing a lot of the European experiments that shall be running on the European payloads that we are supporting on ground. And this is our main job. It takes a long time to prepare experiments in space because we are trying to minimize all the risk associated with them. But whenever we are flying them then into space, we are in close collaboration with the scientists. So they either are on their own location. We have possibilities of using a user home base so they can see the telemetry of their experiments. And we are basically discussing with them over phone, as well as having the experiment payload developers, as well as we are also having then the payload developers of the facility that we have to all collaborate with in order to see if there are any problems that we can encounter them, actually solve them, so we have successful science and experiments in space. The ones that we are supporting are these ones down here. So they're actually quite very big, and they're standard racks, so you could basically also change them in the different locations within the American sector. So they would not fit in the Russian sector. And we have Material Science Laboratory, or the abbreviation is MSL. It's mainly for material science. We have different alloys that we are heating up to a temperature of 1,500 degrees, and then we're cooling them down, and we want to see what the properties are changing in the alloys. We have the European drawer rack, which the current installed electromagnetic leviator. It's again, it's like material science. We can have small probes that are actually then floating and going to be heated up in space. And we have BioLab for biological experiments, and doses which are small, like this orange. Orange is the payload. And you see Matjaz then at the moment showing them because they can switch the locations across the ISS and then measuring radiation. Then I told you most of our time is actually planning all the experiments. And we see here from the European Space Agency how it's the current overview, how do we do this. So we start already 5 years before the planned execution of an experiment. And it's about, and then we go closer and keep also checking how is the status of the experiment, are there any delays, how is everything working, is the scientist happy with the development of the experiment. And so we're going then closer and closer to the more short-term and real-term planning. And there I would like to say that every day, at least on the European side, is reviewed at least 3 times. So 1 week before, we are checking exactly the timeline of their day, what we want to do. We are seeing, is everything looking okay? Do we have enough resources? Are all the documents ready for their day? Is the start time okay? Do we have connection? Because we do not have all the time constantly connection to the ISS. We're using teacher satellites with KU and S-band. So we have to check all of these, and we check it basically at E-6, at E-3, and at E-1. So to really try to minimize any kind of problems that we can already see, and we would like to make sure that everything is looking good before we're actually executing them. Here you see the ISS flight plan. So of course, we plan everything, as I already heard, and we love to also check about all the supply missions. So it's a lot of information condensed on 1 page of a PDF, which NASA is sending us regularly. It's a working document, so it's keep on changing. And for us as a flight controller, it's important to understand, is there a slip in the launch plan for the next rocket, where maybe one of our experiments shall be flown on this one, so that we can already plan then our operations according to that, because we have 24/7 operations. We have to make sure this is fine. And you're going to see also which ports that I showed you before are being used, as well as which Soyuz, as well. You can see which crew is all the way on the top was on board. It's like 1 year ago. And you see also EVAs, the extravehicular activities are going outside of the space station. The blue means it's a US EVA, and red means it's a Russian EVA. We have like 2 definitions of time-wise that are important for us. One is an increment, so it's the period between consecutive Soyuz dockings. It's around 3 to 6 months. So normally they're always coming very regularly, so we're using this also for planning and for what I showed you before, technical preparation of experiments. An expedition is more from the view of the astronauts. It's between the handover of ISS commands. And this is actually, so whoever would like to become an astronaut, a show of hands. 1, 2, 3, I hope more. Who has applied this round? Not yet? Oh, one, okay, great. So warnings. We are trying to follow this kind of like flow charts, so we have to always exclude that there's no emergency on board the ISS. We say, okay, it's emergency, yes, no. Then we have warning events and caution events, and these warning events could be like we lost the battery power and we switch to redundancy, then we would get a warning, and we're trying to work this because if the second battery or like several of the batteries we fail as well, we may lose any kind of storage capabilities on the ISS, so we're trying to avoid these. So we always, when we're going to get pop-up messages, and for the warnings as well as emergencies, the astronauts will also hear several sounds, so we'll be aware of that. And then we always look, and we always would go on the loops and say, what has happened, which sequence to work, who has to work it, and what do I, for example, have to do as a payload center. I may have to put my payload in a very specific configuration in order to work that, and also then where to start, and for that we have also very detailed procedures. If we need then something that they have to plug something from primer to backup, we will call them up and say, okay, look, please do that. We have detailed procedures. Yeah, and I will just skip this a bit. We also have kind of like pre-operational sets, how to work together with international partners, as well as how does the KCC works together with the payload centers. And then, of course, we also have a lot of sets of documentation, what is hazardous, and so on, that's actually going to be put back in the procedures. And as a flight controller, know them, follow them, and maintain them. So for the experiment preparation, I hope you have seen this baby one already in your study. So it's a kind of like normal phase of any kind of experiments you're going to see. We are focusing on this part, and there we're actually reviewing the documents. We have to test them. So every experiment that is flying on space was tested at least once on ground to also see if any of the procedures are working, if the hardware is working, it can communicate, and the science outcome is what we want to expect. And we develop then the procedures, this detailed experiments, and then we operate them. And so you're going to see we mainly, so as a payload center, we are already basically part of the preliminary design review all the way up then to the whole operation, and also maybe then when it's coming back, if there was anything wrong, we're also going to help identify and discuss this. For the MSL, I already said a bit what we're doing is mainly for solidification of metal alloys. And there, I would like to give you a short overview how we actually send commands. So we're working there closely together with the NASA colleagues. So we're sending command from Cologne, Germany, all the way to Huntsville, the payload center of NASA. Then this will be then forwarded to Houston and White Sands, which is a big tracking station. It will go up to the Teeter satellite, and the Teeter satellite will then relay it to the ISS. And for the telecommands, or the telemetry, we're going to have the same way back. We have mainly very good connection with the ISS, so we can even have video and kind of like real-time communication with the astronauts. So from the payload's control center, whenever I would like to have an experiment, I will communicate with CallFlight, and he will then actively listen, give me feedback how this works. If I want to turn on my payload, I will actually coordinate with Stratos, who's responsible of all the resources, water cooling, and can send commands to switch on the payloads. You cannot just go and flip the switch. This all is done by ground and with commands. CallFlight also always have to cross-check with the ISS flight, who's also then checking with his flight control team if everything is looking good, if there's enough resources available. And if we want to communicate with crew, we have Eurocom. And Eurocom then can send over space to ground any message you would like to tell to the astronauts. And here you see again Matjaz installing the material science into the material science laboratory, one of our cartridges. I try if this works. See? It doesn't. So basically, this is an example of how like an astronaut will call out for a question, and then we are trying to coordinate the answer. And you can see here we have voice loops for every position. And if it's like yellow, it means we can only listen. If it's like green, we can also talk on this loop. But I'm going to switch because I have like a backup slide in case it didn't work. So we have call signs, and whenever we want to call, we are then saying call flight, more scopes on call flight loop. So we have to identify who we want to talk to, who am I, and on which loop of all the ones you saw before we are actually going to do this. And the response is very important because you need to be sure you got the let's say that they know that I want to talk with them, so that they are ready to receive the information. So they will then say, okay, Muscops, I've heard who wants to talk to me, call flight, that's them. And then they will say, go ahead. It does not always have to follow, so there's also a bit of flexibility, but then we would discuss whatever I want to say him. So for example, hey, I'm seeing advisory on my payload, what do we do now? Or like, I'm reporting it. We have then, now we have a quick change. I wanted to give you, because, sorry, I'm a bit late, I think, what kind of experiments we're actually doing. So we have for the biolab experiments, small containers and also big containers, which are built depending what the scientists would like to do, and they include everything. The payload for this one is called like the biolab rack, And we have 2 centrifuges, which you see on the total right. And one would be used then for 1G control, one is microgravity, and we would have one ground experiment for comparison, especially for biology. It's very important, so that we do not test how it actually was flown up to space, so high gravity shall be excluded in that sense. And this we're going to do to check with 1G if it's the same reaction of the cells on ground in 1G, we know it's fine, and the microgravity run would then really reveal what kind of microgravity conditions we're having. And so I told you the next experiment will be Giuana Space. It is more for the long term of humankind in space. So we're going to send up real human skin that was cut and then it was sutured back together. And we want to see how actually it heals in space. So because right now we're trying to avoid all of that, and maybe if we're going to go further into the universe and into space, we may going to need also capabilities to operate in space. And this would be like one of the experiments leading to that, what is different on ground to in space of the human body. So I'm almost done. So what kind of uncertainties do we always fear also in payload operations experiments? Is anything like new requirements of any kind, or from the scientists, from the payload developer, something that didn't work? Politics, yeah, as you saw, it's a bit difficult at the moment. Budget cuts, always space is expensive, and we are trying to achieve as much as we can with the money that we are having. And then we have kind of also rocket delay, so we have shifts of the rocket launches because of whatever, as well as like COVID, which we didn't really anticipate, which also caused a lot of delays in our experiment development, so that we are not so much in time. So that's why some of the experiments can have several months, as well as sometimes years delays, unfortunately, before they actually, the scientists actually get their results. But we are actually getting better with that. So that we have around turnaround of 3-4 years for experiments at the moment, and for not so complicated ones, it can be even up to 8 months. And I'm going to finish my talk with what sometimes as a flight controller, you said we have everything kind of prepared. We're trying to be as prepared as humanly possible. But then you think you're going to receive something like that, and the reality looks more like this. So thousands of cables, everything is a bit messy. The astronauts sometimes cannot find even what we are looking for. And all of this is then things that can cause a bit of discussions on the loop. And that's why we actually plan everything, because you can plan as much as you want. It will always come a bit different as you expected. So with that, I'm thanking you for your attention. And I'm also, if you have questions, I'm happy to answer them.
Okay, so I think we have time for a couple quick questions. Anyone have any questions? Please put your hand up and I'll pass the mic to you. Sorry, we only have time for a couple. First, we'll just go over here.
Yeah, hi. So what do you think the coolest experiment on the ISS has been?
The coolest experiment, there's a bunch. I think right now there was one that is about like concrete in space. So how does concrete is different from ground in space? And of course, I like a lot of the biology experiments that has been done. So, and there has been a lot of them, so I cannot really pick which is the coolest. So there's really a lot. So I think the Giuana Space one is really nice, and also one of my favorite is cytoskeleton, which just ran December to January, where I was actually personally involved. So it was about like cytoskeleton, so how does like the cells change in microgravity, which will maybe also help understanding like how does cells elder, and this can also help us on ground understand some certain kind of diseases. So, yeah.
Thank you.
You're welcome.
So, other questions? Yep.
Hello, this one's probably a bit uncomfortable, but with current sanctions, do you see an influence on the collaboration effort on the ISS?
So I understand the the security sanctions. So I cannot really talk much about it because I'm the wrong person to ask, because it's kind of like above my decision. So at the moment, as I said, crew safety is very important. So we have to keep everything together for now, as we still have humans in space, and space is difficult. So we're trying to have to work together at the moment, and we're going to see how actually it's going to turn out. So they are discussions above that, a bit more, have a bit more autonomy between the two different sections. At the moment, this is still very closely waved together.
Great, thank you very much.
Okay, I think we have time for one more question. Maria, if you're happy to speak to people after.
Yeah, I'm happy if you can come to me as well, and also if any questions, let me know.
Sure.
There's one over there as well.
Questions? Yeah.
Hi, quite a boring question, but given Brexit and everything, how will UK students get to work for a company such as yours based in Germany? What would the impacts be on that?
For Brexit? I mean, again, I'm not 100% sure. It's like my human-person relation, but we have at DLR 96 different nations that actually work at DLR. So there are ways you just kind of like then apply, and normally you can have a working visa, of course, and I think that is independent from Brexit. So, and I think DLR is very open for international people working at our facilities. And for example, ESA itself is independent from Brexit. So the UK is part of the European Space Agency. So that's already then like no restrictions there.
Brilliant. Well, thank you so much, Maria, for a wonderful talk. As Maria said, if you have any more questions, you can find her throughout the conference and ask her in person. We're now going to take a quick 5-minute break to hand over to the next speaker.
who's also a business intern, and they're going to talk about how Skyrora is ensuring that the future of the UK space industry is sustainable. So, go ahead.
Yep, so Skyrora is a Scottish aerospace company. We have our headquarters based in Edinburgh, and we have sites across the UK and the rest of Europe. So Skyrora specialise in the design, manufacture and launch of rockets to cater for the small satellite market looking to access space. So Skyrora are all about achieving accessible, cost-effective and most importantly sustainable launch. So we are in the development stages of our innovative technologies, and I'll take you through a few of these at the moment. So we have our multifunctional launch vehicle, Skyrora XL, with in-orbit maneuverability capabilities. We have our mobile launch complex. We have our EcoScene fuel made from non-recyclable plastics. And just to kind of make you aware of our cutting-edge 3D printing technology, so with additive manufacturing, it means we can simultaneously print composite components, something which isn't readily available in the aerospace market at the moment. So I'll take you through more of these as we go throughout the presentation. So to cover what Skyrora have done so far, in 2018 we launched our first suborbital rocket, Skylark Nano, and this launched from the northeast of Scotland. In May 2020, Skyrora were the first to successfully static fire test a rocket in 50 years in the UK since the Black Arrow programme. And later in 2020, we went on to launch our second suborbital vehicle, Skylark Micro, from Iceland. So with all of these missions, and as well as the upcoming launches of our Sky High vehicle and our Skylark L vehicle, we take an incremental step-by-step approach, which allows for critical testing and de-risking, meaning we can test our advanced technologies before we go on to launch our commercial Skyrora XL vehicle. So Skyrora's aim is to support the growth of the UK space sector and ensure that launch can become sustainable. So first of all, we have our Skyrora XL vehicle, which is our main launch service. And with this, we have in-orbit maneuverability. It uses proven technology from the Black Arrow programme. So the Black Arrow programme ended in 1970, and with this, they use a propellant combination of hydrogen peroxide and kerosene. Now, the ratio Skyrora uses for this is eco-friendly. Using less kerosene, we reduce CO2 emissions, and we ensure that our launch can be sustainable. So moving on to EcoScene. EcoScene is in the development processes, and this is the aim to replace the traditionally used kerosene at the moment. So EcoScene maintains the capabilities of current kerosene and oil-derived fuels, but it is made from non-recyclable plastics. So with a catalytic pyrolysis process and hydrotreatment, we can also reduce emissions during the production process. We can reduce emissions by up to 70% during this production process. During testing of the EcoScene fuel, it was found to be almost 50% less CO2 emissions during launch, and with our 3.5 kilonewton engine testing, it was also 1 to 3% more efficient. So with this, we can reduce secondary microplastic production, we reduce emissions during launch, and reducing waste in landfill. So overall, this is a really good alternative for our satellite customers. Moving on to our mobile launch complex. So with this, we are providing a flexible, accessible launch process with decreased costs. The systems are modular and easily scalable, and it contains everything required during launch. So we have our fuel filling systems, oxidizer filling, compressed gas supply, command center, mobile power station, all the way to transporter, erector, and launcher. So as well as decreasing manufacturing costs and setup and pat-down costs, it improves logistics, and from an environmental perspective, this is really useful as it leaves little damage on aerospace infrastructure, on the surrounding environment, as we can pack up and move on. Moving on to Space Tug, so you're hopefully all aware of the severe problem of space debris at the moment. So with space debris, we are at the risk of damaging satellites which are so essential to us now for Earth observation and monitoring the climate to prevent climate change. So with Space Tug, we can reduce the risk of damage to satellites. The technology is based on the third stage of Skyrora XL, and it's compatible with this third stage and with the payload that it incorporates. So with this, we can clear orbital debris, we can deorbit spacecraft, we can refuel spacecraft, and we can carry out lunar orbits and interplanetary missions. By deorbiting space debris, we're reducing the risk to satellites that we rely on now for Earth observation. So overall, Skyrora are just passionate about achieving environmental launch and expressing the importance to all of you heading towards a sustainable UK space sector. When in orbit, we are relying on satellites to provide us with the essential information we need to look after our climate. But how can Skyrora and the rest of the UK space sector work together to achieve this globally?
Hi everyone. So you may have heard the term net zero circulating lately, especially with COP26, which just happened in Glasgow. But just to remind you, net zero is essentially a global objective to mitigate the effects of climate change by ensuring the amount of greenhouse gases that we are adding to the atmosphere is no longer the same or more than what we're taking out. So the UK government has committed the UK to reaching net zero emissions by 2050. But we all know this is going to require significant levels of investment, collaboration, and strategizing across all sectors. So let's talk a little bit about how we can achieve net zero here on Earth. So in 2015, all UN member states adopted the 2030 Agenda for Sustainable Development. This is essentially a set of 17 key goals that are key to achieving net zero for peace and prosperity for people in the planet, now and into the future. So some of the areas that this initiative addresses include poverty, health, education, gender equality, clean water and energy, economic growth, innovation, and climate action, just to name a couple. But it's quite notable that of these goals, 15 require satellite technology to achieve. And this is because satellites provide valuable Earth observation data, which is central to achieving net zero across the Earth by 2030. So let's talk a little bit about why satellites are so central to net zero on Earth. Just to name a few examples, overseas, satellites are enabling researchers to track winds, waves, sea levels, surface temperatures, pollution, and biological activity. On land, satellites are helping to monitor crops, forest, soil moisture, urbanization, snow and ice cover, landslides, and flooding. And satellites can even help tackle certain social issues. So that would include, allowing doctors to monitor and treat emergency cases in the long term, contributing to disaster management and relief, fighting the poaching of endangered species, and ending even modern slavery or human trafficking. I think it's important to circle back to these sometimes and just emphasize how important satellites are to everything in all aspects of our daily lives. And I think Jonathan Bamber from the University of Bristol sums it up quite well here with this quote. So, Earth observation satellites are the eyes of our planet, and without them we would be virtually blind to the magnitude and timing of climate change. But the unique remote sensing and observational capabilities that satellites give us are not available to us in the long term if we don't fight now to preserve the precious domain of outer space. So how exactly can we achieve net zero in space? So basically, as commercial and private activities in space enter this new era of growth, the risk of orbital debris is increasing exponentially. And according to the UN Office for Outer Space Affairs, there are approximately 900,000 pieces of space debris which are currently orbiting Earth, just as we're talking now. And the debris has the potential to stay in orbit for hundreds of years. This is incredibly dangerous because it increases the risk of collisions between space assets. I'm sure you've all heard of the Kessler syndrome, affecting the safety and sustainability of space operations, and even increasing the cost of access to useful orbits. And back in 1967, Article 1 of the Outer Space Treaty states the exploration and use of outer space is for the province of mankind. What does that mean? Essentially, in my mind, that means protecting Earth's orbital environment has to be central to all space activities in order to preserve the domain for the future activities and ensure those UN Sustainability Development Goals will actually be achieved. But this is only possible through the sustainable development of the public and private space sectors, as well as international, multi-stakeholder cooperation, civil society, academia, public authorities, and regulators' activities in space. So this is exactly why in 2021, the Paris Peace Forum met to launch the Net Zero Space Initiative. So a bunch of stakeholders got together and they discussed achieving the sustainable use of outer space for the benefit of all humankind by 2030, taking concrete actions to tackle the challenge of reducing debris orbiting Earth. So this initiative is essentially comprised of two key objectives. One, to avoid the further generation of hazardous space debris, and two, to remediate existing hazardous space debris. So we've talked about net zero on Earth, we've talked about net zero in space, and we've talked about Skyrora. But how do all of these things come together? How is Skyrora contributing to net zero space? So we've drawn inspiration from Prospero, which is a satellite that was launched successfully by a British rocket just over 50 years ago, the first of its kind actually. So this was launched from Woomera, South Australia, and in 2018, Skyrora went there, recovered the first stages from their landing site in the outback, and the artifacts are now on display at the Farnborough Air Sciences and Trust Museum, if you ever want to go visit. So following on from this, we've launched a nationwide challenge to retrieve Prospero, which has been endorsed by the Space Minister, Amanda Soloway. We believe locating and deorbiting the Prospero satellite is one of the first key steps in demonstrating to the rest of the world the UK's commitment to tackling space debris. And our space tug, which Molly touched on earlier, this can also help and remove defunct satellites from orbit. We've also created a framework called the Prospero Principles, and this is communicating the importance of this mission and what will be required for us to truly approach net zero space. It's made up of 6 key pillars, which I'd like to go through with you just now quickly. So the first one is responsibility. Space players have to practice responsible launch and space usage by mitigating the environmental impacts of space activities. And Skyrora plans to do this through our EcoScene fuel and mobile launch complex. The second one is cooperation and interoperability. So this means, governments, businesses, and other users of space need to work together to coordinate all space traffic to minimize the risk of collisions. Thirdly, transparency. To hold citizens and governments accountable, it would be beneficial to make data about space debris and what's actually orbiting the Earth widely available so the wider public can have a better understanding of it. The fourth one is inclusivity. So space is a domain that's available to everyone, for everyone. Therefore, we shouldn't discriminate against any specific group who would like to access the space industry, including discriminating for ethnicity, sexuality, disability, etc. And that's why at Skyrora, we really aim to hire individuals from a wide range of backgrounds to gain that unique perspective on the space industry. The fifth one is conservation. So the future missions have to ensure debris is limited. Governments and businesses need to strive to ensure that no matter what materials we're using, there should be none actually wasted. So that's why, as Molly mentioned, we use additive manufacturing to produce all of our rocket components at Skyrora, and we house one of the largest 3D printers in Europe as well. And additionally, stakeholders must ensure the responsible disposal of inactive devices and space waste. And once again, Skyrora's space tug technology is central to achieving that. Finally, heritage and education. So space has to be preserved for the future generations, and this will only be achieved by educating young people and also engaging with heritage professionals, helping everybody to understand their place in space and how we can preserve it for the future. So essentially, the UK space industry needs every single one of you sitting in here to carry on this torch of net zero space and create a sustainable future that will benefit all of us. And from firsthand experience, I know that the space industry seems quite challenging to break into, especially as a fresh graduate. But I want to ensure you all of your contributions, no matter how small or large, are key to the future of sustainable space. So how exactly can we inspire the next generation of students looking to find their place in the space industry? I'd like to take this opportunity to just briefly share my experience of working at Skyrora and provide a bit of advice to anybody who is looking to enter the space industry. So as you can probably tell from my accent, I'm from Colorado in the States. My background is in international business and journalism, and music as well, actually. So I've always been really interested in global affairs and the role they play in business environments, but clearly this degree combination doesn't really have much to do with space at first glance. I went to Australia. I was working for a record label there. I realized my passion for PR and the editorial field. And during my final year of university, which was during COVID, I had literally no idea what I was going to do with my life. And a lot of people were telling me, just apply to companies you're interested in. There's no point in just not applying. You never know what might happen. But I still wasn't encouraged. I knew for sure I wanted the role to be creative, as I mentioned, but also operate in that international environment. And although I've always been really passionate about space and participated in STEM programs, I never in a million years thought I would be working in it, especially in Edinburgh. But now my role at Skyrora, I would say, could not be more of a perfect fit for me at the moment. It requires creativity to curate promotional campaigns, to spread the word about current events in the UK space industry, such as World Space Week, COP26. I also get to utilize my editorial and writing skills on a regular basis to facilitate press releases for Skyrora about key milestones and achievements. And I'm required to stay up to date about the global space industry and political climate to spread the word about our mission in the most beneficial way possible. So why am I telling you all of this? This is because I want to give some advice just now. Firstly, I would really encourage you when you're applying to different organizations in the space sector to think outside the box. Of course, we all know the traditional space roles like engineering and astrophysics are really central to the sector. There's no doubt about that. But so are the less traditional ones, like PR, business development, law, finance, art. There's so many things that go into creating the space sector and being successful. And so I encourage you to not be discouraged, essentially. And also, lots of graduates don't have that industry experience. I definitely did not. So think about those broader skills that are needed to succeed in the fast-moving space industry. What are some of those? Innovation, creativity, analytical thinking, leadership, a willingness to learn, and just show employers rather than tell them how you can, contribute this. And this will benefit you in your future space careers, hopefully. So now I'd like to give the floor to some of our current business interns at Skyrora to share their experiences.
So I took a slightly different path to Nikki. At school, I was really interested in maths and physics and graphic communication. So ultimately, this led me into a product design engineering degree. So I'm still currently studying this now. I'm in my 4th year of a 5-year master's degree. And with PDE, the thing that I really liked initially was the wide variety of skills I was required to have, not just going into the degree, but also that I would be equipped with coming out of the degree. So at the same time as beginning studying university, I always had this keen interest in space. When I was 11 years old, I went to Florida and saw the last shuttle launch. And from here, I went on to read books written by astronauts, watch talks, and ultimately knew I wanted to steer my career towards the space sector. So at university, I looked out societies. I joined the GU Rocketry Society, which you might have heard of, and this was my first glimpse of kind of a fast-paced project totally orientated around the space sector. With this, I worked my way up to become the head of business and operations, which I currently still do at the moment with GU Rocketry. And with this, there was kind of a bit of a fork in the road with my career. So GU Rocketry was very business orientated, but alternatively, I was studying an engineering degree. I was studying mechanical engineering with the creative side that product design brings. So it includes everything from branding, marketing, cost analysis, hands-on manufacturing in the workshop, CAD, you name it. And so I had to kind of decide where I now wanted to aim my experiences. And I was finding I was really, really enjoying the business roles and the part they had to play in the space sector. And I was obviously very aware of Skyrora at the time. And when I saw that their business internship was available, I applied straight away. One thing I would say about this, I think it's very easy to shy away from applying to jobs and with the fear of being rejected. But I would say that the experience you get from writing applications, writing cover letters, going to interviews is so, so valuable. And even if rejection comes along, which it will for all of us, the amount you learn from that is so, so valuable, so don't let that be a factor when applying for things. I was lucky enough to get the role at Skyrora, and straight away I loved being flung into a fast-paced environment, working on real-life projects with deadlines and contributing to a project that really matters and can really make a difference. My role requires me to be knowledgeable about the company. I've spent quite a lot of time learning about what we do in order to apply for conferences and grants, and obviously come and speak to you guys today, writing technical articles and that sort of thing. And throughout all of this, I've really, really valued the people I've been surrounded by. So I'm in the business headquarters, and being amongst people from so many different backgrounds, so many different degrees, is so rewarding, and seeing what everyone has to bring to the table. And so if I could give you any advice, it would be that don't let the title of your degree define you. So a lot of you might be doing very similar degrees, or we could all be from slightly different backgrounds, but ultimately it ticks a box on your application. But it's everything after that that employers look for, particularly Skyrora, looking for driven people who are passionate about something. And so it's less the title of your degree, but more the person you've become throughout all of it. And so when you're listing your experiences, it's not a job title, it's the skills you've learned from that, whether it's stacking shelves or working at a checkout. You'll have experiences throughout your life that have made you the person you are today. And it's that employers look for, and it's that separates you from hundreds of other applicants. So if there's anything you take from that, it's just really show the value of your experiences to employers.
Thanks, Molly. So yeah, I think as a trio, we definitely prove Molly's point that the title of your degree really does not define the career that you're capable of. I myself am in the third year of a psychology degree at the University of Glasgow. And what's more, I really went through high school with no discernible talent in STEM at all. I performed really well in English and languages, and to be honest, I spent years wondering what on earth these skills would be useful for. I actually started university as an English literature student. I went to a few lectures, realised I couldn't survive 4 years of it, very quickly transferred into psychology, a subject which I'd only had a glimpse of towards the end of my high school career, but one which I find really fascinating. It was through these studies in psychology that I came to realise how much I cared about and enjoyed research, especially research which could be applied to real-world solutions, and this plays a really big role in what I do now at Skyrora. So my only real prior experience of the space industry was as a complete outsider. I used to look in and awe at all of the achievements that were being completed right throughout the industry. And similarly to Molly, there's a bit of a theme, but I also visited Florida and was lucky enough to watch a launch when I was younger, and after that I spent many an afternoon sort of gawking at YouTube, watching various companies launch rockets, somewhat bittersweetly because I never really considered aerospace to be an industry that I could break into at all. This was, of course, until I saw Skyrora's internship advert, which I immediately screenshotted. I sent it to my dad alongside the message, and I quote, "How cool would this be? They don't need me though." And then I scrolled right on past and never thought about it. It wasn't until my dad responded to me and pretty much questioned why not that I thought, yeah, true. I revisited the advert, I submitted an application with very high hopes and very low expectations. To my surprise, I was invited back for an interview, and at that point, as Molly said, I really just felt lucky to be able to meet with the Skyrora team to discuss the UK space industry with people as passionate as the Skyrora team. And what's more, it was so inspiring to see the headquarters and to know that all of this fantastic work was taking place not only in the UK, but for me, less than an hour away from where I lived. So following 2 rounds of interviews, which I'm lucky enough to say ended well, I've now been with the team for a number of months, and throughout this time I've had a fantastic opportunity to utilise my psychology education to contribute to all sorts of various projects. I've had the opportunity to work really closely with our engineering team. I've met incredible people like yourselves from all across the industry, and I've got to do all of this enjoying the fact that we as a team are making real change in the UK space industry. So I think for me, the most important piece of advice I can offer is not to let a preconceived notion of a job or even of a whole sector deter you from just having a go at it. If you find a passion, no harm can come from chasing it. More and more in today's working world, it is things like transferable skills and a real work ethic that define a desirable employee. And I like to think that I'm a good example of this because I can honestly say I have employed my psychology education more than I thought was ever applicable to the aerospace industry. Contributing effectively to any role in any sector is way less about fitting into a box now, and it's more about being able to climb up on top of that box and shout about your skills and your ideas and your experiences that other people have never even considered. All right, thank you so much for listening to us. We really hope you learned something. We hope that we've inspired you to consider your place in the industry. I think we'll have a couple of minutes to take a couple of questions, and we also have a booth upstairs. We'll be here all weekend, so please feel free, come by, have a chat with us, and have a great weekend. Thank you so much.
Great, thanks a lot for that. Any questions from the audience? Anyone?
Hi there, thank you very much for that. That was really interesting, and as you can probably hear, I've also come down from Edinburgh. But I wanted to ask about the Scottish Space National Strategy has just been published, and Wales have just done the same thing, and like what you were talking about, they've really put sustainability at the heart of it. So I wondered if you have any thoughts about how the public sector and the private sector can work together on that, because with the space industry developing as it is, it's not just big nations that can take part, it's small nations like Scotland and Wales and also like the UK that can do it.
That's a really good question, actually. Yeah, so for those of you who don't know, the National Space Strategy was recently published, and it's outlining how the UK can kind of bring all of their resources together and create this space industry that has never existed here before. And it's all starting with the strategy. And I think the purpose of a good strategy is, if it's properly implemented and drafted, it should go down to the grassroots, which are, you know, the SMEs and the smaller businesses. And it should also go right up the way, and the strategy should be mutually beneficial for everybody. So this requires, like we were even talking about with the sustainability aspect of this strategy, significant collaboration across the sector. And I think that Skyrora is really leading that at the moment in Scotland. And so could you, sorry, what was the rest of your question actually? I was just asking how different the public sector and the private sector work together on sustainability and other kind of public goods initiatives. Yeah, of course. So that's kind of another interesting thing about Skyrora. We're kind of working with the regulators at the moment to create some of these legislations that have never existed before in the UK. So it's constantly, and even the Prospero principles I was mentioning before, this is a way to kind of create a framework that we can communicate to people and put it into sort of like a context that they will understand to get the similar goal communicated to everybody. And I think that it really requires that collaboration between, you know, the government and the SMEs. And a lot of times the government is quite focused on those big players, which are incredibly important as well, you know, like Lockheed Martin, for example, or Airbus. But it's also requiring everybody's voice to be heard. And I think that's a challenge that Skyrora is kind of working on at the moment, is getting our voice heard, working with the government and working with larger corporations to make sure each part of that value chain is being realized. So does that answer your question, hopefully?
Great, I think that's all we have time for. Any more questions for Skyrora? They'll be upstairs in their booth. We have a short announcement now for the Institute of Physics, and then we'll go on to our break.
Thank you. Hello. Not free yet. 30 seconds more of your time I require. Thank you for that wonderful talk. My name's Julian. I'm from the Institute of Physics, the professional society and professional body and learned society for physics in the UK and Ireland. And I'm going to be doing a talk in the break room for about 5 minutes, talking all about the support you can access, the resources, the funding, grants, events, blah, blah, blah. Wonderful things that you can access when you are at university and as you transition into the first steps into the workplace and so on. Quick thing about the Institute of Physics, we're here to support a very diverse, inclusive community of scientists, physicists, engineers, anyone with a connection to physics. And I would encourage you all to go onto the website, have a look, potentially apply to become a member, which costs just £15 a year, and is a fantastic investment in your future. What do? We campaign. through events and activities. We campaign on a government level to promote physics, and on a local level through our branches, our special interest groups, and through conferences and so on, and through publishing. Physics World you may have heard of, to ensure that physics delivers on its exceptional potential to benefit society. Like I said, come and hear about all the wonderful things you can access for your professional development, something that you're all engaged in right now in this room, which is fantastic to see. But there are more things you can do through events, through building your skills, your confidence, and your knowledge of the landscape to make more informed decisions as you progress through your career. So come and find us and ask yourself this question of what can I do now to build my own skill set, build experiences, and build a network that is going to be able to both improve your position, your employability, and prove to employers you have the skills to succeed in that job. There's a lot of things you wonderful people can be doing. So I hope you enjoy the rest of the conference, and do come and talk to the Institute of Physics at either now in the next 5 minutes or at any point during the weekend.
who provide a lot of amazing software solutions for space-based projects of kind of small sats and things. And yeah, she'll tell you a lot more about it. But they've had a great history of working with us at UKSEDS, and we're very, very happy to host them here again now. So yeah, I'll hand over to you.
Great, thank you so much. Hi, so my name's Shannon. I'm a ground software engineer with Bright Ascension, and I'm here today mainly to talk about our Bright Start academic program. So I'm going to start off by telling you just a few words about the company, who we are, what we do, and what our experience and heritage is. So we are a space software company based in Scotland. We offer innovative products and services focused in the software domain. Our first mission was in 2014. It was a mission called UCube-1, which was a 3U CubeSat for the UK Space Agency. So on that we did the flight software, the ground software, and the simulation software. Today there are at least 29, I'm pretty sure it's about 33 now, spacecraft using our software, and there's many more in development. I think there are about 8 or 9 more missions that are due to launch at least this year. So our software is used for a really wide range of applications, from technology demonstrations to Earth observation, remote sensing, communication missions, etc. The list goes on. So we are global. We have customers all over the world, and many of our commercial customers are now expanding into constellations as well, which is really cool to see. Easy scalability being one of the main features of our software. So some of our missions as well are R&D focused. We're involved in a lot of collaborations with universities, commercial organisations, and national institutions or agencies like UK Space Agency and ESA. So what we offer is off-the-shelf and readily available flight and ground software products that are flight proven. Like I say, at least 29 spacecraft are flying our software, and at least half of them are also using our ground software for operations. So at the heart of our software is an innovative component-based approach which creates limitless combinations of both pre-validated and bespoke software components, which means that our software will suit even the most unique or bespoke specific missions. So the reason why we started our academic program is because we know from a lot of work we've done with previous universities that student budgets are very tight, and most of the times too tight. So we know how hard it can be to find affordable and reliable software that can really make a difference and help to reduce your development time. So we want to support the academic community and help future skill building. So that's why we've come up with Bright Start. So Bright Start is a program that's specifically developed to be used in an academic environment and includes 3 main components. The first being specially designed license plans, which is for both our flight software and ground software products. The second is training and support. So we understand that simply having access to our software is obviously not enough. So we include multiple help and support options, which I'll go through a bit later, as well as sponsorship. So at the start of each academic year, we offer to sponsor up to 3 student missions with a flight ground software bundle. So we have 2 types of product licenses that we offer as part of the program. The first being the classroom license, which is entirely free of charge, and it can be used for evaluation, education, learning, and pre-development. And the second one being, if you get to a point where you actually want to build a flight-ready spacecraft to be launched into orbit, you may want to apply for a flight license. While you do need to pay in this case, it's worth noting that I think the price that we offer in the academic program is at least half what we charge for commercial organisations. But both licenses have the same set of features and offer the same support options as well. So, of course, it's not simple enough getting access to software. You may require access to training and further support. So we're not specifically able to offer individual help desk support, but there are a lot of other options, and we won't leave you on your own. So we have a member-exclusive forum for mutual support, so you can ask other members questions. We'll be active on there and respond to stuff. We also offer fairly regular training sessions, either monthly or quarterly, which will be a full dedicated, I think, day helping you get set up. And then we also want to inspire student teams across the world to collaborate and share ideas via the forum or one of our Q&A sessions. So we are passionate about space and we want to be part of the most exciting missions. So at the start of each academic year, we select up to 3 student missions that we sponsor with free flight and ground software, which is equivalent to our academic flight licenses, and that's all free of charge. So we had 2 winners this past year, just gone, the first being AirSat-1, which was the first Irish satellite that was developed by the University College of Dublin, and the second being Sea Lion, which was a demonstration mission launched into a very low Earth orbit with non-rechargeable batteries, so the expected lifespan of that was about 10 days. So it's incredibly easy to apply. Simply tell us about your project by filling in a form on our website, and if you visit us on our stand today or tomorrow, you can find out all the details from us on how to hopefully become our 2022 winners. So we're not complete newcomers in the academic world. Over the years, we've been very privileged to support a number of academic institutions across the globe. Some of them on the screen there. These are some of the larger projects that we've had. We've seen good interest and uptake in our academic programme since we launched it last August. Our Bright Start academic community is constantly growing, and of course we always welcome new members. So just very briefly, a few words on what we actually offer as software products. So at the moment we have 2 core products, the first being the Flight Software Development Kit, which is an innovative development environment for creating your own unique mission-specific flight software through our extensive library of pre-validated components. So the component-based approach ensures that you are able to develop faster, launch sooner, reduce risks of failure, and ensure that your flight software is reliable, efficient, and most important, cost-effective. And then our second product is our mission control software, which is just a nice, easy-to-use interface for monitoring and control and automation of onboard changes during flight and development. So the real advantage of the MCS, which I think other operations software will find quite hard to beat, is in its seamless integration with our flight software. So both products use the same underlying technology, which means that your mission will require little or no configuration or ongoing maintenance for your spacecraft operations. So if anyone's interested, please join us on our stand. We're giving out product demos today and tomorrow, and we're more than happy to take you through all the aspects of our main software products, show you how they work and how they can benefit your mission, and we're also happy to give any more details about the academic programme, how to apply, and anything else you may need to know. So just to sum up, the real aim of this is to give you access to mission-proven software, but to allow you flexibility in how you use it and how you apply it to your mission. So that's partly to allow to customize everything your mission, but also to maximize the ability for you to learn from what we are providing. So thank you very much, and if anyone's got any questions, please don't hesitate to drop by our stand.
Thank you very much once again to Ascension for sponsoring and supporting our conference. We're now going to move on to the Spaceports panel. We tried to get all Spaceports together. We've only managed to get the 6 out of them, but it's still a record-breaking number to have here together. It's going to be led by our beloved trustee, Matjaz Vidmar, who's going to walk us through what the Spaceports have been doing over the past few years and what the future's looking like for the sector, and especially for the careers future. So Matjaz and the rest of the people, please, over to you. Can we please all welcome them all onto the stage, please? And may I just remind everyone, if you want to submit questions that you might perhaps not want to answer, raise your hand up. And similarly, people at home, if you want to submit questions, UKSEDS.org/NSSC/questions. Just replace the captions line with questions. Matjaz?
Excellent. Thank you so much, Antonio, and thank you so much, everyone, for joining us in this stream for the UK Spaceports panel. As Antonio said, I'm delighted to be here, partially because back in the day I was actually setting up one of the first UKSEDS branches in Edinburgh, but also because today we really have managed something that's quite incredible. I mean, there's some government committees where everybody can come along, but pretty much everywhere else it's really hard because there's so many interesting developments across the UK in spaceports industry that having 6 of you here is a sort of special achievement. Of course, all kudos to UKSEDS, incredibly hard working organizing committee that issued invitations and managed to secure you all. So I won't spend too much time chattering away because we have to hear from all of you. So I'll just do a very quick introduction. As Antonio has said, it is really a really exciting time for the space launch industry in the UK. Very soon, we think, first sort of civilian orbital rockets will be launched from I don't know, if this is a little bit of a race, which one is going to be first, but we will definitely, you know, some people promising even before the end of this year to see some first UK orbital launches. So that will be really, really exciting. We know there's lots of challenges here, regulatory ones, to trying to get the approvals, as well as a lot of industry development, infrastructure development needs to happen to enable all of this. And we'll try and cover as much of that as possible in this panel. Now, in rough order, so we are delighted to first go to Cornwall. John Parffett is the Commercial Director of Spaceport Cornwall, and quite an exciting place. We know that you guys were a little bit ahead of the block in the beginning with sort of famous contract with Virgin Orbital and all that stuff. So we're excited to learn more about your plans. Mark Roberts, who is Defence and Security Lead for RIA Group and Project Director for Spaceport 1, which is in Western Isles. So I'm based at the University of Edinburgh, so this is the first of the Scottish ones on this panel, and in a place called North Uist, and we'll hear more about the beautiful landscape there and how it is already home to some of the rockets that are being tested and launched, and how that will expand with Spaceport 1. John Whalley, who is the Chair of Space Wales, representing Spaceports for Sondonia Consortium, and as was already mentioned today, recently released a report, or strategy for the development of space industry in Wales, which I'm sure we'll come back to. Then back to Scotland again, Ben Jarvis, who is the suborbital launch campaign manager for KCL Awards Spaceport on Shetland. Lovely place, the furthest point of the UK that you can kind of get to. And if you're lucky, I'm sure they'll show you around the exciting site where they're building KCL Awards Spaceport. Then we have Victoria Montag, Chair of Discover Space UK, and who are leading the operational arm of Spaceport Macaranesh, which is near a place called Campbelltown, if you're Googling. And that is also in Scotland, but the other coast, so sort of in line with Glasgow, but further west. Yeah, Google Earth, check it out. And then finally, Peter Guthrie, who is the head program manager for Space Cup Sutherland, which, you know, speaking of places far away, is also in Scotland and is the furthermost part of pretty much Scottish mainland. So that's before you get to Orkney, so the Shetland Islands. That's kind of the corner. So you see the vast geographical distribution. Of course, the plans differ in other ways as well, not just their location, but also we have some vertical spaceports. So you know, rockets as we kind of imagine them, as well as some horizontal ones, which means rockets strapped underneath planes or other drones or other kind of vehicles to deliver in orbit and then launch from there. So lots of exciting stuff to cover. So the plan for this panel is to have a quick sort of round of personal introductions, a little bit about each of the speakers' career and how they end up heading the various parts of the spaceport development programs, and then a little bit about the respective spaceports, at which point we're going to open the floor for questions. I have some pre-prepared ones, but I'm sure you're all dying to find out more about these spaceports, so we'll very much welcome the questions. As Antonio said, if you want to submit them online, just replace that last bit there with questions. Otherwise, if you're here in the room and you're courageous enough to put your hand up, then just put your hand up and one of our helpers is going to get the mic to you. So over to John to introduce Cornwall. Yeah, that's fine.
Perfect. Morning, everybody. So my name's John Parffett. I'm the Commercial Director for Spaceport Cornwall, and I'm also the founder and Managing Director of a company called KISP. KISP is a program and systems engineering company. I've been in the space industry for about 30 years. I was fortunate to hear a talk by a gentleman by the name of Sir Martin Sweeting a long time ago, who was talking about doing space differently, about putting small spacecraft into orbit, and I thought, wow, I want to do a bit of that. So what am I about? I'm all about trying to drive the utility and application of space, or the sustainable, responsible use and application of space. And as a company, we're really fortunate because we get involved in a lot of really interesting projects with a lot of bright people. And in fact, you know, one of the reasons why I've stayed in this industry is because, one, it's very inspirational and it's fascinating, but also because it attracts some real talent, and it's great to work with really brilliant people. And so one of the projects we've been supporting is Spaceport Cornwall. Fortunate enough to start off working with Virgin Orbit on bringing, well, first of all, securing some money from the UK Space Agency. That was fun. And then on the implementation of that program, and then more recently supporting Melissa and the Cornwall team on putting the infrastructure in place to enable us to do launch from Cornwall this year. So in answer to the question of are we launching from the UK, the answer is yes. When will it be? It will be this year. Why did we get involved in the Cornwall program? The thing I like about the Spaceport Cornwall is what we're basically doing is we're taking an existing operational licensed airport and turning that into a spaceport. And so it's intrinsically a very sustainable business because you're basically taking an existing operation and just adding another service. And for those of you out there that are not aware of the Virgin system, it's basically a converted 747. You might not know, but a 747 has actually got a mount for a fifth engine so that they could go and fix a broken down 747 if there was one to arise. So what Virgin have basically done is they've attached a pylon under which they put the rocket, and so basically we have the rockets taken to Cornwall, we integrate the payloads in a payload integration facility down at the airport. It's strapped to the bottom of the 747. The 747 then takes off out of Cornwall, travels for about 100 to 150 kilometres, and drops the rocket, and off the rocket takes us into space. So really exciting, and it's going to be great to see that happening this year. It's been a long time coming, and a lot of hard work and blood and sweat in getting to where we are today, but it's a really great time to be in the industry, and it's a really great time to see these things happening in the UK. And the thing for me that really excites me is it helps stimulate the community into thinking, wow, what can I do now that we have those capabilities in place? So what I'll be looking at in the future is people in this audience that are coming up with great ideas for space and spacecraft systems that can be deployed using some of these systems. So that's us.
Thank you, John. Mark?
Good morning. It's really good to be here. I was asked to give a tiny little potted history of my background and then a little bit about the spaceport. So my background is that I was in the Air Force for far too many years, spent a lot of that time flying fast jets, but latterly ended up, because I was having too much fun flying fast jets, in the Ministry of Defence for about seven years. And as part of that job, I had responsibility for UK space policy, would you believe? When I left, I then went into essentially cybersecurity, started to run a business on cybersecurity, and the company that I worked for was approached by the Western Isles to assist them with this new thing called space. Because I could spell space, I ended up in 2015 getting involved in the Western Isles, and I haven't left it since. So I've been in the spaceport game, if you like, ever since its very earliest days. Like John, the thing that excites me, and I recognise that I'm sitting here very old looking at the future of space in the UK. I haven't got much longer in my working life, I hope. So my role really is to create the conditions for a fantastic space industry. We'll do my little bit for you guys. In a sense, that's what drives me. A little bit about the Western Isles. We started the project, as everybody else did, trying to capture the what was perceived to be the big prize, which is orbital launch. For a variety of different reasons, we detuned that, and now the site that we are just about to build is focused on suborbital launch and solely on suborbital launch, but fairly of vehicles up to a fairly significant size. So we are essentially trying to segment ourselves into that corner of the market, which is a bit of the market that's not particularly well researched. But since we took that strategic change in direction, we've had a really quite overwhelming response, and I think we can create a sustainable business around suborbital launch. There is one thing that I would say. We are talking to a number of universities about doing rocketry, both here in the UK and overseas. One of the things that I would say is that our business model allows us to essentially help to stimulate that activity, primarily in the UK. So if you're sitting there thinking, this is something that I might like to get into, or I want to set up a team at my uni to make this happen, then please come and talk to us, because you might find that, and certainly we have found with various discussions with universities, that the perception of the cost of doing suborbital launch is not consistent with the truth, and actually you can do suborbital launch comparatively inexpensively. So now I don't know if the questioner is here. I can't actually see her, but there was a question about sustainability, public-private sustainability during the Skyrora session, which the Skyrora team gave a great answer to. I would just add to that one of the things, in addition to the regulation, that's what everybody sort of is drawn to. One of the things that the public sector can do for all of us actually is to be a customer of us, and particularly around sustainability goals. We are all aiming to provide services that directly feed the sustainability agenda in one way or another, and that is a very good way for the public purse to enable that to happen.
Thank you so much, Mark. The other John on the panel.
Borodapau. Good morning, everyone. That's all the Welsh you're going to get this morning. I'm not going to tell you my life history. If he thinks he's old, I'm positively antediluvian. I've been around a very long time. The reason I'm still here is because the world is so exciting, and it's what's happening in space, I think, which is the key to that. You talked about our space strategy.
John, can you switch the mic on just so the audience online can hear us?
Okay, you talked about the space strategy earlier on that's just been launched for Wales. So I just want to set some context, because your point about we need customers is very important, and having that value chain, that ecosystem within our regions and within the UK, I think is really important. It's only by working together that we'll make spaceports work. They don't work if they're just standing alone. So Wales is a small country. People often talk about the size of Wales. You know, we've lost the equivalent of 9 Waleses worth of tropical rainforest. So people use the Wales as a unit of measurement. If you think back to that light map that you saw, Wales is pretty dark. All that bit in the middle is very agricultural. There's a big chunk of light in South Wales, and there's a big chunk of light along the North Wales coast, and that's where most of our industry and people are based. So we have a country of about 3 million people. It's about 5% of the UK population. But if you look at aerospace and defence, which is well established in Wales, we have about 10% of that industry in terms of the numbers of people employed. So we arguably punch above our weight. When it comes to space, there are some challenges. We were about 1%. I think we've probably grown closer to 2%. So we've got some rapidly growing companies across upstream and downstream. We have what I call our 3 stellar startups. One is Spaceforge, which is here today. They're launching in-space manufacturing capability and bringing stuff back, which is important as well. So they'll be bringing their orbital vehicles back to Earth. We've got B2 Space, who are using stratospheric balloons to launch near space kit. but also now developing a concept called the Raccoon, where they launch a rocket from the stratospheric balloon, giving you a very low-cost access to suborbital space, potentially. Spaceports Snowdonia is really a consortium of organisations, of which Aerospace Wales and Space Wales is one. We're kind of the Welsh equivalent of NASA, although we have a rather smaller budget and only 5 people, so that gives you some idea of the size. But we sit in that space. We're actually an arm's length body of Welsh Government, but we also have over 200 industrial members as well. Those organisations are growing quickly. They're looking for talent, so if you want to come and work in Wales, there are lots of opportunities. Come and see me afterwards. Spaceports Snowdonia's ambitions this year are to do some of the things with some of the companies I've talked about. So B2 Space will be launching from Spaceport Snowdonia. Spaceforge will be launching from Cornwall using Virgin Orbit, because that's probably the first opportunity that they have to launch in the UK. But their ambition is to come back to Wales. That reminds me of a song, you know, but to land in Cardigan Bay. So off the coast of the west coast of Wales, we have an area of 7,000 square kilometres of segregated airspace. That can be switched on and off. And the intention is to bring their orbital space vehicle back into Cardigan Bay and then bring it back onto shore to Llanbedr. So some exciting things happening over the next few months. Real launches taking place, real returns taking place. And you know, Wales is not Fortress Wales. We have to work in partnership across the UK and indeed across the globe. So I look forward to working with everybody on this table and also lots of you in the audience. Thank you very much. Diolch yn fawr.
Thank you so much, John. Should we go all the way to the other end of the country now? Shetland.
Hi, everybody. Right, so quick personal introduction first. So I didn't start out planning to have a career in space. I actually trained in product design and graphic design. So I'm very much at the A bit of STEAM. But my involvement in the space sector actually started from being interested in rockets as a hobby. And for which I blame my dad. My dad was involved in special effects, and I spent much of my childhood watching him blow things up. So I was one of those children who liked playing with matches and things that I shouldn't be playing with. Luckily channeled that into positive and constructive things by the time I was a teenager, and set up a amateur rocketry organisation who did quite well. We developed our own hybrid rocket engines, and were part of the sort of amateur space race back in the 1990s, trying to be the first to put an amateur rocket above the Kármán line. I then sort of got dragged into commercial rocketry, probably about 25 years ago now, and I have been asked to do lots and lots of crazy things with rockets, everything from the sensible end, launching educational payloads, all the way through to building full-size working Scud missiles for illusionists in Hungary, and making rocket-powered cars and rocket-powered garden sheds for TV science shows, and all kinds of crazy stuff. More recently, I've spent the last sort of 5 years working in commercial suborbital launch vehicle development, initially for Skyrora, built and or designed the first couple of their small suborbital rockets, and then set up my own company, which I worked with for a couple of years, developing suborbital vehicles, before last year making final sideways move to work with Saxavord, helping them achieve the first sort of commercial launches in the UK. So I'm technically the suborbital launch campaign manager for the Spaceport. So the Spaceport, obviously, like everybody, was very focused on orbital launch for the first few years. The UK space industry was sort of very much focused on that very specific prize. And as Mark has said, over the last sort of few years, everyone's starting to realise that suborbital launch is also a big opportunity. So, introduction to the Spaceport. Saxavord is the UK's Pathfinder Spaceport, so that is, it's got the sort of government-backed first orbital launch demonstration flight, which is due to take place later this year. It's thankfully after a very long battle, finally got its planning permission. So the diggers have started moving. We have actually started digging ground. The spaceport is actually physically being built now. Yeah, that's been a long old battle. And it's obviously it's the most northerly, as already been mentioned, most northerly of all of the spaceports. So we're on Unst, the northernmost tip of Unst, which is the northernmost of the Shetland Islands, which is it's a long way north. But the advantage that gives us is that we've got basically clear sea all the way to the Arctic Circle. So there's nothing in our way. So we've got a sort of 60-degree arc of clear space to launch both high suborbital and orbital vehicles from the spaceport. Last things. One of the things that, interestingly, we're sort of very focused. I've become very, very focused on sort of opportunities for students. I've been involved in student rocketry competitions for like 28 years now, and if I achieve nothing else in the rest of my career, I want to be able to sort of create as many opportunities for students and student teams to be able to get access to space launch capability in the UK, and I think that's probably echoes what everyone else is saying. I think you are all at an amazingly lucky point right now. I wish I had been at university now, because you've literally got a whole bunch of spaceports fighting for you to come and launch rockets with them. So likewise, we're looking at we're obviously mainly a sea range, but we're looking at another area of land that we own, that we're looking to make a land range for small student launches to be able to take place as well. So, yeah, if you want to get involved, either talk to Mason, who's sitting back there, who I'm going to point out, waving his hand, who's our education officer, and yeah, between him and the rest of the team, we're basically very keen to speak to any student groups who want to come and get involved. And I think the key about all the spaceports is that they are kind of closing the circle for the UK space sector. So we've always been good at building satellites and the sort of downstream using data and things like that. And the only bit that's been missing is, being able to actually put stuff into space. And you are all, as I said, very lucky to be at the point where we are within months of that finally being possible within the UK. So, congratulations on being born at the right time. Yeah, I think that's it. Come and have a chat if you want to come and launch some rockets.
Excellent, thanks, Victoria. And of course, Campbelltown, it's famous for the fact that it was a diversion landing strip for space shuttle.
Yeah.
So you have a very interesting space story there.
Hopefully, yeah. No, hi, I'm Victoria Montag. I am a director and also the chair of Discover Space UK, which is the operational arm of Spaceport Machrihanish. Which one am I using? Either. Can you hear me? Yay, nay? Okay, well, good. Like Ben, I didn't plan on ending up in the space sector. I left university, I worked this out yesterday, 15 years ago, with a degree in physics, and I wanted to be a nuclear physicist. The broad plan was to leave university, spend a year working, and then go back to university to do a master's. Obviously a PhD, and then become, this brilliant Nobel Prize-winning scientist. 15 years later, I'm a director of a spaceport, and I don't have a master's, so that says something about my career. In those interim 15 years, I spent some time as a tutor. I was a research scientist doing high-temperature radiation thermometry at the National Physical Laboratory for a number of years. I spent some time as a lobbyist in the manufacturing sector, and then by complete accident, by chance, I found myself in this brilliant, exciting industry, which is just, as Ben and everybody else is saying, it's getting really exciting right now. Spaceport Machrihanish and DSUK, like some of the other spaceports, we looked at the big launch picture, and we've decided to put a pin in the orbital launch market for the time being. It's not completely ruled out, but we'll leave it to Cornwall and the others for the time being. What we're more focused on at the moment is areas around skills, education, research, test and development. And some of you, I think, would have already Googled Campbelltown, because I think probably there's a number of you coming to Mac 22 this year. No? Yeah? Yay! Fingers crossed for good weather. For those of you that don't know, our Mac series of competitions launched last year with a CANSAT competition from UK and technically international universities. This year we're going bigger, and we've expanded that to a rocketry competition as well. And Rosie, my outreach lead, is doing a fantastic job planning all that. Alongside that, like I said, we're looking at test and development. So we are currently working with universities and also low TRL launch service providers for testing their their research engines. We're also looking at novel engine testing. And yeah, like I said, just low TRL, companies who want to test their capability. Our ambition, though we're not looking at orbital launch at the moment, is still quite ambitious. I keep on saying that I want to turn Spaceport Macrahanish into the Mojave of Europe. It might take some time, but we've actually got started, and it's quite exciting what we're doing right now.
Excellent, thank you. And last but not least, Sutherland Spaceport, again, another Scottish one to wrap us all up. Peter.
Great, thanks. So as Ben said, yeah, I think you're all very lucky. It's a great time to be starting to get involved with the space industry. But you're also very impressive. Because I think when I was a student, I would have still been in bed at this point after a night on the beers. So the fact that you're even awake is quite good skills, I think. I work for an organisation called Highlands and Islands Enterprise, and we're the Scottish Government's Community and Economic Development Agency for the north and west of Scotland. And in 2018, we applied through the UK Space Agency for grants to progress the Space Hub Sutherland project, which we won, which was great. And ever since then, we've been progressing with our project to build Space Hub Sutherland, which is right in the north coast of Scotland. We did that in concert with a company who are based out of Forres, which is in the Scottish Highlands as well, and they're called Orbex, and they're actually building the vehicles which will launch from Space Hub Sutherland. I still have to kind of pinch myself, quite honestly, when I go into the Orbex headquarters, their factory, and you actually see rockets being built right in front of you, and it's quite extraordinary to think that's happening in the Highlands of Scotland. Usually, we're really challenged in the Highlands of Scotland that we're so far away from everything that it's quite difficult to persuade somebody to build a factory or something like that. But the space industry is one of these amazing opportunities for the Highlands that we, because of our geography and because of the physics, we're the perfect place in the Highlands and the Islands to base a spaceport. So we think the future is very bright for spaceflight from the Highlands and Islands. We recently undertook some market research which showed that the addressable market for satellites being launched from the Highlands and Islands of the sizes that would be launched from Space Hub Sutherland or Saxiford or Spaceport 1 or MAC is about 82 a year over the course of the next 10 years. So given Space Hub Sutherland, we have a limit of 12 launches a year. It's safe to say there's more than enough business to go around. And that's great news for you guys, right? Because that means employment and it means opportunities. Like others in the panel, I think I did a PPE, as it used to be known, politics, philosophy and economics. And I became a civil servant after that, working in broadband deployment. It's funny, there's quite a lot of people work in space that used to work in broadband deployment, I don't know why. It's a geeky element, I suppose. And I've been doing space full-time for the last 4 years or so. So it's a fantastic future and great to see you all here today. Thanks.
Thanks so much, Peter. So we've got some time for discussion now. If there's any questions in the room, that'd be great. Just make yourselves known. And a microphone will go to you. I think there's one over there, or one or two. But in the meantime, I'll just throw one question there, which is something that a lot of people here will be wondering about. You talked about all these beautiful places, quite remote, quite pristine nature. How are we dealing with the environmental impacts? I think this is something that a lot of, particularly with the concern we have around sort of carbon and just how much we, pollute the environment. How we, would anyone like to kind of make a particular comment about that? Because I think it's something that a lot of people would be interested in. Okay, right, Peter, back to you.
So we're confident that we're going to be building the greenest spaceport in the world, and that's a bold claim, but we've got the science to back it up. So for first of all, we'll be limited to 12 launches a year, so the environmental impact of that is not particularly high. On the ground stuff, we're building on a peat bog, but that peat bog is very degraded, has been degraded over hundreds of years by peat cuttings. And one of the great things about peat bogs is if you restore them, if you make them wet again, by damming them up, they can start sequestering carbon again, so that's great news. As well as that, you know, in terms of the launch operations, the Orbex Prime rocket uses biopropane and liquid oxygen. So that reduces launch emissions, CO2 emissions by up to 90% over kerosene-based fuels. In addition to that, and very importantly, it produces virtually no soot, no black carbon as it goes up as well. As well as that, the Orbex rocket is reusable, so that helps reduce the footprint there as well. But we also have to be really open about this. You know, spaceflight happens, right? We've got satellites, we need satellites. So if we're going to launch satellites, let's do it in a much more sustainable way. And that's what we're looking to do from Space Hub Sutherland. So we're looking forward to that first launch in a couple of years' time.
Okay. Thank you, Peter. Would anyone else just like to add anything? But do we get the microphone up there? Yep. No.
So
yeah, just very quick because we are running a little bit out of time. And
okay. Well, you mentioned our strategy. It is Wales a sustainable space nation, and for a very good reason. If we don't get it right, the Welsh Government won't allow us to continue. We have to make sure we green the up side of space as well as the downstream side, which is clearly a big challenge for us all. But there are developments taking place in biofuels and so on, which will, I think, make a significant contribution.
Thank you. Right, let's take that question from... Yeah.
All right, so I had a question about the possible limitations. So especially for the more northerly spaceports, you're obviously quite far away from the equator, and as such, as I understand it, it'll be quite hard to launch satellites into geostationary orbit. Is there like an inherent limitation that comes about from the fact that you're so northerly, and that any communication satellites would obviously have to pay like a premium to then go into geostationary orbit? Do you see any issues associated with that? Is there just going to be some sort of like ceiling for how many launches and how much business you get from communications companies?
Would anyone like to explain that we're not doing geostationary launch? Yeah.
Let me answer that. So you're right. If you think about space, historically, and the most commercial thing that's happening today has been geostationary communications, a unique orbit where the satellites are going around the Earth and at the same speed at which the Earth's rotating. So it's a unique prime real estate, as it were. That's not the only orbit that's now used by spacecraft. And if you listen to the press at the moment with the systems like Starlink or OneWeb or man of other systems, they're all using low Earth orbits. And so when you actually start looking at other applications like remote sensing, actually a preferable orbit is what we call sun-synchronous, so near polar orbit. And so actually the UK is well placed for addressing those orbits. And to the point about the market and the market share, actually it's about being in the right place to do the right trajectories, as it were. So the UK is well set up for doing launches into polar and sun-synchronous orbits, which is then well in tune with the sorts of capabilities of the launch vehicles that we're looking to launch out of each of the spaceports. Really just building on the sustainability point, the other point I should point out is why the UK? Because actually there's no unique launch, unique UK orbit. It's actually one about convenience and about sustainability. So the advantage of launching a remote sensing Earth observation spacecraft, for example, out of any of the spaceports in the UK means that I don't have to travel halfway around the world to deploy my payload. But you're right, it means that our addressable market is one that's geared really towards the polar and high inclination orbits.
Can I just say that I think I'm right in saying that the study that HI conducted did not include GEO either, did it?
No, it didn't. No.
So those numbers that were quoted to you earlier are for what we can service from the UK.
Right, sure.
We talked about the 7 spaceports, I think. There is an alternative which is being developed, and that is sea launch. So we have a company called Black Arrow Space Technologies who are looking to establish a base in Port Talbot in South Wales and actually launch from sea, so they can go virtually anywhere in the world. That's at a very early stage of development, but it could, address that issue from a UK perspective. But I share the comments of the rest of the panel. There's more than enough market to go at now that can be accessed directly from the UK.
I know we've got more questions here, but we also have an online audience we do not want to neglect. I think Antonio's got a question from online.
Yep, I'm
Yep,
checking
we
if
can hear
this mic works. There's quite a few online actually, but given time, I'll use one of the short ones. Why so many spaceports?
Right, who'd like to crack that particular nut?
Go on, I'll do that one. Because there's lots of money in it. That's quick question, quick answer. Yeah, no, I mean, there was a point at which, as I said, I think probably 10, 15 years ago, before I was heavily involved in this, where the UK realised that there was that gap in the circle in the UK in terms of being able to actually fulfil launch from the UK rather than people, as John said, having to carry their payloads all the way around the world to launch them. And, you know, the launch market is becoming more and more commercial. 15, 20 years ago, 70, 80% of all satellites launched were launched for governments, and now 70, 80% are launched for companies. Yeah, it's something that people want to be able to do it quickly, cheaply, and locally. So, and as has been said, there is a lot of opportunity. There's something like 175 companies developing new launch vehicles at the moment globally. So whether all of them will succeed is another matter, but yeah, I think having that sort of competition is a good thing. It's encouraged everyone to work a little bit harder as well.
Excellent, thank you. Yeah, sure. You can quickly, then just if you get the microphone just over there, but keep it very brief, right?
Yeah, I wouldn't disagree with anything that Ben would say, but the money is not what's driving us. And I think one of the things that it does, this particular corner of this particular industry, launch does, is it enables parts of the UK that wouldn't naturally attract this sort of high quality, you know, forward-leaning business into some fairly poorly served areas. Orbital, there might be a lot of money in. Our business plan turns all of the money into jobs for the local area. So that it is not an investment vehicle. It's not, and nobody's going to get rich on it. And I can't think of another business that would naturally fit on the islands where they are that carries the cachet of space.
Excellent.
Hi, so the thing that I think is most exciting about the Sutherland Spaceport is that it's a project that's a partnership between a public body, a private enterprise, and a community group, Melness Crofters. And it's actually addressing local issues like the peat degradation you mentioned, and also depopulation and a lack of good jobs in the area. We've got a wide range of different spaceport projects here across the UK. How do you think that they can solve local issues in their respective communities?
Yeah. So, how are your spaceports addressing local issues in economic development, community development, etc.? So maybe just one or two, because yeah, okay, Victoria and John.
So at Spaceport Machrihanish, thank you. At Spaceport Machrihanish, we're based at what used to be a NATO airbase, and they shipped out, oh God, I can't remember, I'm really bad at my history, but a while ago, and that left a big hole in terms of employability for the local community. So I know it's all words, but we're very, very conscious that the actions that we have on site, it has to be for the benefit of the local community. So the first thing that we're doing is we are creating a community hub. So this is really going back to the skills and education. The local community, they're our neighbours, but they're also our suppliers, and they're our potential employees. You know, we've already employed 2 people from the local area. Small start, but it's a start. So how do we get the local community to have the skills that are relevant to what we need? So we've applied for grants to create this community hub, which looks at educating local school children, you know, all the way from school children up to adults, to really, really develop those sorts of skills. I think that's...
And it's very much at the heart of Spaceport Cornwall. So Spaceport Cornwall was not set up by a bunch of space business people. In fact, I'm probably the only space person in the team. It was set up very much as an economic development and regional development activity. There's a lot of deprived regions within Cornwall, and a really big part of the programme is around the whole STEM and outreach and capability development. And so we did an activity with the students. We had about 5,000 students over the summer, trying to inspire not just the students, but also the parents of the students. What we find is, within Cornwall, there's a view that if you want to be involved in engineering or science, you have to leave your families and leave the county and go elsewhere. And that's not true. So a lot of what the programme is about trying to both attract industry into the region, but also show the opportunities to people out there. And so, in addition to the Spaceport program, another initiative they've been moving forwards with is the KNOSAT program. And this was about making space relatable to the local community, so Cornish programs for Cornish needs. And this first program is an environmental monitoring spacecraft. You know, Cornwall surrounded by coast, and it's about making it relevant. So that is really, you know, what does success look like for the Cornwall team? It's not the number of launches going on. It's about the growth of the community, both at the schools and the colleges and the universities and industry, and that's very much the heart of what they're trying to do. You know, we focus on the launch, and that's one of the bad parts about the space industry. We all get so excited about what we're doing, we become very insular. But actually, it's about cultivating that entire community. And so what success looks like is basically enthusing and encouraging and growth of the wider ecosystems, where the launch basically becomes the sort of the icing on the cake.
Thank you so much, John. And I think at this exciting note, we should close this panel. Thank you so much, both all our guests, as well as, of course, all of you who tuned in. And I'll hand over back to Antonio and apologize for running a little bit late with our program today, but so much excitement here. So please join me in welcoming and thanking our panel today. When's the next launch? When should we tune in? July for Cornwall. Anyone else? Can be July?
B2 Space, I think, is possibly going to be April.
April. Right? Tune in. NASA TV, I guess.
Thank you once again, guys.
Okay, everybody, let's settle down after lunch. Everybody find a seat, get comfortable. I just wanted to start by saying that this year, as UKSEDS, we've really tried to focus on emphasizing that space is not just about science and engineering, but that space has an impact and requires absolutely everybody. Katy Haswell actually exemplifies this principle perfectly. As a journalist, she's worked on covering multiple launches from the Giuana Space Centre, including the James Webb Telescope. She's now going to give us an insight as to the space world from the viewpoint of a journalist, demystifying and showing us what the space sector looks like to the public. Thank you.
Thank you. Thank you very much, Zara. Well, I'm really, I have to say, I feel very proud to have been invited to speak here, and thank you for having me. And thank you to you, because you're the young people who are taking us into our future, and all the work and studying and all the stuff that you're working on today is shaping our tomorrow. So I thought we should start by you giving yourselves a whopping great big round of applause. Well done, you. So I work in, right now I have to tell you, I'm a journalist, right? And I am not a scientist, I am not an engineer, but I have been working in broadcasting most of my professional life, and that's quite a long time. I'm not going to tell you how long, but it's a long time. When I first started out in the media, there was only TV, radio, and of course print, magazines. And newspapers and stuff like that. But of course we didn't have the internet, we didn't have mobile phones. And I remember when I was a young radio reporter, BBC local radio, you used to have to carry this great big equipment, recording equipment, a very big, heavy, reel-to-reel recording, no little natty digital recorders back in those days. And I remember when my news editor sent me out with one of these and said, you better take this with you. You keep in touch while you're out on the story. And I thought, oh God, how am I going to carry all this stuff, and be interviewing people as well at the same time. And then, of course, things really moved on, technology moved on. And I remember jumping out of a car in front of the camera for a TV show saying, this is the very latest in mobile phone technology. So yeah, things have moved on. And we didn't have the internet. So when I was a young journalist, we used to have to spend the day phone bashing, trying to find out about the story and who we were going to interview. Story, which has really changed. That's just an aside. So space is very important in the media. It's inevitable because it's so inspiring and it's so exciting, and of course it's informs everything really, from big budget movies, sci-fi movies like The Martian, down to 5-second TikTok films via Discovery Channel, the BBC, the big documentaries, YouTube, websites. It filters into everywhere. And I kind of think that there's, not just for space, but in the media generally, there's kind of two sides of it, because there's the big mainstream side, all the TV channels, etc., and the websites. But then there's also the sort of internal organizations, because if you think about where do you get your footage, if you're a reporter, let's say you're doing a report for the BBC on an asteroid that's heading towards Earth and going to smash us all up, where are you going to get your footage? Well, you're going to get some of it from, you might go out and do some filming, you might go and do some interviews, but you're also going to rely on the big organizations like the European Space Agency, NASA, the industries, and they make lots of animations and they supply lots of footage and interviews and filming for journalists and program makers to be able to bolt together and make their shows. So that's really where I come in. because I'm a broadcaster. So I started out in BBC Radio, and I ended up reading the news on ITV, BBC, ITN, and I've done lots of travel shows, and they really are great. I really enjoyed it. It's hard work, but it's really great. But I'm also I've spent 20 years hosting the live broadcasts during launches from the Giuana Space Centre, and I have to tell you, I feel unbelievably privileged, because I was trying to count the other day how many launches I've seen. I think it's probably about 70. So I've done a lot of launches, and I've met unbelievable people during that time, and it's been really fantastic. And I also work with the European Space Agency and also NASA, and that's been really fascinating as well. And big industries like Thales Alenia Space and Airbus. And so I thought, now, to make a movie work, do I literally just click on it over? Where's the technical people? I thought I'd just show you a bit of me in years gone by. Now this is I just wanted to. Oh, right, okay. So do we have sound? Because I as I said, I've spent many years in this business, and you're going to see that I look an awful lot younger in some of these clips than I do now. But anyway, this is just to give you an idea of. I've got lots of little videos to show you, so I do hope that we can get some sound. While we're working on this, does anyone have any questions so far? How many people here are interested in working in some way, shape or form in communications or the media? Yeah. So there's quite a few people. And out of curiosity, has anyone actually been making your own movies, or making movies on your own cameras, for example? I mean, your phones. Yeah. So a few people, yeah, yeah. And has anyone done any? Yeah, in your make. I can't hear you, but we do have a mic, so it might be a good idea just to use that.
I was just going to say, as part of the Open University Space Society, we actually hold media events, so we host speakers and have live events, and also have stuff on YouTube and multimedia for people to engage with, so we do that, yeah.
Oh, so you're very experienced then, you do a lot. Yeah, you do. So the Open University is such an important, vastly important resource in space. I mean, obviously the Open University is doing some amazing research, has a very important space department, but the Open University also funds space shows and makes a lot of, not just space, but some really great programs. So I'm just wondering whether we may be...
We have one more question.
So if you were going to give advice to people who, like, say, are just starting out, wanting to go into a career in kind of like science communications or just communications in general for space companies, like Zaria said, like this conference is for people of all backgrounds, not just technical, and you know, like there's so much opportunity. Like, what advice would you give to like those students and young professionals that are looking to kind of make a break into that sector?
Yeah, no, so that's really important, and I something I was planning to talk a little bit about. So why don't we talk about it now? Because well, we're trying to get some sound up. So I think, you know, things have changed radically, really, because so there are ways to become a journalist, say, or a presenter, or get into producing in television and radio. And obviously, people do sort of big, media degrees and all the rest of it. I can tell you what I did. I did a one-year postgraduate course, which was fantastic, and it really equipped me to walk into a BBC radio newsroom and literally pick up the kit and operate as a radio journalist. And from there, I then started. Is my mic still working? Can you hear me? Yeah. And after that, I then went on to read the news. But radio is a brilliant way, or sound is a good way of starting your broadcasting career, because it really makes you think about how you tell a story and all the ingredients that you need to tell a story. And I then I ended up doing on-screen work, but it's good, healthy, a producer or whatever. But thank you very much.
Discovered that in some countries here, children are not getting enough of the...
But then...
I've discovered that in some countries here, children are not getting enough of...
Just let it. Oh, I see. Okay. Do you know what? I think I'm going to skip my show reel. We'll move on to something else now. I think you've seen that clip enough times. In fact, let's see if I can skip it quickly now. Right. I'm just going to finish what I was saying. So, but I was going to come on to this later, but there are now, of course, so many different ways that you can do it. Because if you want to get into the media, you can start doing your own podcasts. You can start doing your own. Start your own YouTube channel. And one of the things I wanted to chat with you about later was, for anyone who was interested in doing that, was what the ingredients are to make for making your own shows, because you've got to have stuff to say and stuff to show. But I think that if you start doing it and start getting followers, that can be a good way in, particularly as you have. You have expertise. So when I started out as a journalist years ago, expertise wasn't really the important thing. It was being a presenter that people wanted. Whereas nowadays, people like Brian Cox are hosting shows, and you have that. So that's actually a positive for you as you go into your careers. And remember that communication is vital. Simple messages. And making things simple for people to understand, it's very, very important, because it's how you get your funding at the end of the day as well. So I was a journalist and a TV presenter, and I then went on. I got a call. How did I get into not being a scientist or whatever, into space? I got a call from the European Space Agency saying, could I host a show from a place I'd never heard of, French Guiana. And it was the broadcast during this XMM space telescope, which is still up in the sky, giving us incredible discoveries. It's not going to run out of fuel till 2029. So that's been there for many years. And since then, I've done loads of really fantastic missions, from cargo ships to the International Space Station, little satellites bouncing around Earth's magnetosphere. I've done rocket launches. I've been to the Mission Control Centre in Moscow a number of times to host events during the live broadcasts during the rocket launches. That's Thomas Pesquet's view from the window when he was up there. And I discovered the Giuana Space Centre. So I thought you might like to get a bit of an insight into what it's like. So this is what we're looking at here. So the Giuana Space Centre is in French Guiana, of course. Whoops. Oh, hang on. Wait a minute. There we go. That is not a real rocket. You don't get rockets launching right in the middle of a cluster of buildings. The launch zone is, I think it's over there somewhere. That might even be it there, one of the launch zones. There's a few launch pads at the Giuana Space Centre. So these are administrative buildings. This is the Jupiter Mission Control Centre. And on the side of that, you've got two viewing stations. So you see that line down there? That is they've cut away the trees. So that when you're standing outside here, you can see a direct line to the launch pad. So that's the launch pad there. Radars and stuff. This road takes you all the way down to these different launch zones. It's called La Route de l'Espace, the Space Road. And so, yeah, it's in Brazil. It borders with Brazil. So I can tell you that the caipirinhas are very good in French Guiana, as is the tiponche, which is the local rum drink. It's completely Amazonian rainforest, and the sounds of the birds and the insects, particularly at 6 o'clock in the evening, and the little frogs is just wonderful. And you know, I could listen to it all day. Oh, hang on, I've done something strange. There are some new guards patrolling the CSG perimeters, and I want you to see who they are. So, I'm so sorry, but I'm really struggling here with the videos. Just, oh yeah. Amazing, huh? I've actually seen a sloth trying to cross the road. And one of the interpreters I work with has, she lives in French Guiana, and she said the sloths, they hug, they sort of have this hugging motion, they clamp onto people's garden gates and they can't get them off. Oops, sorry. Well, this is the RM5 launch zone. This is the launch zone here. This looks to me, hang on, I haven't got my glasses on, but I think this is the assembly building. So this is where the part of the rocket's built, and then it's completely all assembled, and the upper stage is hoisted onto it there, I think. I can't remember now exactly. And then it rolls out to the pad along this road, along some very special rails, very, very slowly. And then there's the gantry. It's built on its table, and there is the Launch Control Centre, which is basically a bunker. This is it. It's concrete. So if anything happens on the pad, it's about a mile from the pad, so it's very close. If anything happens, then obviously people are protected. And you have to do special safety training. So you can't go on the base, you can't get a badge or a pass without the special safety training. And so you have to learn all about the different gases and what could happen and the different eventualities and what you do in the event that something does happen. In fact, all the cars, it's quite funny, because when you're in here, they have big loudspeakers letting people know what's happening all the time. And all the cars have to park. You have to reverse in, so that if there was an explosion, you would drive straight out like that. So you don't have people trying to reverse in and out to get out. And quite frequently, you get a great big loudspeaker when you're in there, and they're saying, somebody has parked their car the wrong way around, please go, reading out the number plates, you know. Last time I was there doing my safety training, which you have to do every couple of years, it was a security guard or a policeman who was being hauled out for his car being the wrong way around. Now, this is now the Mission Control Centre. So you've got Launch Control, which is about a mile from the pad. Mission Control is about 10 to 15 kilometres from the pad. And this is the commentary box, and it's overlooking, so that they can't see them, the commentary boxes are up here, overlooking. Can you see this glass? This is called, inside, the mission controllers are there. This is the fishbowl, and these are all the screens that they're looking at, and that's the TV show going out, and that's all their screens. There's the green status panels telling you what's going on with the launch and if it's all green for launch. And this is during the James Webb Space Telescope. We actually, what we did was, I was standing in front of the fishbowl, and interviewing here, this guy's the head of space science at NASA, and we built a little TV set. You can see it there, as you see all the cameras. And to the other side of that are the VIP guests, and then behind me is, again, you can see all the mission controllers. So it's really good, actually, because it means that I can see exactly when I'm commentating, or when I'm in front of the camera, because I've got ideas about what I'm going to say, but I don't have autocue. I'm just basically ad-libbing. And I can see people's faces and expressions. This is quite useful, you know, because you can tell how things are going. Because a rocket launch, of course, you know, anything can happen. You can even have a rocket sort of lighting its engines and then not going off because it's, you know, the main engine is shut down because it may not be functioning properly or something. And then you can just see that we've got cameras everywhere. So there's cameras inside, cameras pointing at the guests, there's cameras pointing at inside the fishbowl at the mission controllers, cameras obviously pointing at the presenters. Got cameras outside because everybody goes to look outside during the actual launch. They go out onto those viewing stations I showed you. And then we've got cameras all over the place. We've got cameras because you obviously need to be shooting the launch itself from every angle. Cameras on the pad. We've got cameras, you know, in different positions. I love that picture, actually. It's really lovely. It shows the rainforest and and then we obviously need long lenses because it's going into space. So we need to film it as far away as we can. And that's an amazing picture. Camera catching the boosters, so they don't drop off till about 2.5 minutes after launch. So that's already at a high altitude. And we need also cameramen and women who are very steady and just following the camera nice and steadily with their tripods. Oh, I had the most incredible experience on one of the launches I did. I was invited the night before launch to go and go to the pad. And that was my view. I took these pictures. I was looking up like this, going, oh my God, it's fully loaded. And this is the, whoops. Oh, anyway. I'll tell you, just very quickly tell you a funny story, because the people I was with said, have a look up. They said, can you see there's something sticking out of the rocket? You can't see it. And it turns out there's little holes in the side of the rocket. And of course, in Amazonia, equatorial Amazonia, you've got lots of insects and lots of stuff flying around. And you know, there's lights on it, there's big sounds of the air conditioning and all these little insects flying around. And they were flying into the little holes. And it turns out that the diameter of the holes was the same diameter as the finger of a glove, of a washing up glove. So they cut off one of the fingers from a washing up glove and stuffed it in the top of the rocket in one of these holes to stop the insects going in. So, what were you doing on Christmas Day 2021, just gone? Were you stuffing turkey, stuffing chocolate, playing with your latest present from Father Christmas? So you might have been watching the James Webb Space Telescope launch, and I was there, and it was very, very exciting, and I can tell you it was one of the highlights of my life. So I'll just show you a bit.
This is live coverage of the historic launch of the James Webb Space Telescope. I'm Michelle Fowler, speaking to you from NASA's Goddard Space Flight Center in Greenbelt, Maryland. Well, I'll be anchoring coverage from here at NASA Goddard. The big stuff happens today here, at the Centre Spatial Guyanais, the Giuana Space Centre in French Guiana. Katy Haswell is there at the launch facility and joins me now live via satellite. Okay, how are things in Peru, Katy?
Michelle, things are looking really good. The boards are green, the mission controllers are focusing hard. We are go for launch. We've had our eye on the weather the last couple of days. The weather's been a little bit inclement, so we're keeping an eye on that. But otherwise, everything's looking absolutely great. And I have to tell you, there is just such a buzz of excitement here in the Mission Control Centre. It's a remarkable feeling. Right now we're topping up the tanks on the upper stage of the vehicle. So we've got two great big arms called cryogenic arms, and they clamp onto the upper stage and they pump in the cryogenic fuel, which has to be kept very, very cold. So it has to be topped up right until the last minute because it can evaporate. You'll see those arms kind of falling away just before launch in the last couple of seconds. So up here in the Sky booth in the Mission Control Centre, we have NASA's Rob Navius and the European Space Agency's Luce Fabregat. They're standing by, hi guys, standing by to take on the commentary when we get to about 15 minutes to launch. But right now, Michelle, all the boards are green. We're going for launch. Back to you, Michelle.
I wanted to show you the launch, but I'm not sure how to fast forward that. So no, so let's forget it. Yeah, no, I'll just forget that. I'll just so okay. So I mean that was, you know, that goes on for another sort of 30 minutes or something. But the launch itself. Oh, it was amazing. It all went absolutely like clockwork. I was really nervous standing in my little set beforehand because you know, you've got 10 billion pounds of space telescope and sort of nearly 30 years of some people's lives sitting on top of it, you know. And if something goes wrong, then, you know, that's a big loss. So thank God it didn't. It was a fantastic Christmas present to humanity. I thought you might be interested. So Rob Navius, the guy you saw there who did a little wave. Now he is the voice that you often hear on NASA broadcasts because he's he's often known as the voice of NASA. So it was a real privilege to work with him, and also Michelle Thaler, who was the James Webb Space Telescope presenter in the Goddard Space Centre, and I was co-hosting it with them. And it was really interesting to work with NASA and see how they do things, and from a TV perspective. And one of the things that he did is during the launch, he said some really memorable words, and you'll see them at the end of this film. And I thought it was interesting. I just did a little interview with him on Zoom or something the other day, just so that you guys could hear what he was thinking when he was doing the commentary for that, because you may want to do commentary yourselves. I'll talk more about that in a second.
The world was watching, and you knew that the information you had to provide had to be precise, and you knew that you were at the tip of the spear of something that was going to unfold over the course of decades to revolutionize astronomy and how we view the universe. For launch, I knew that, well, we were originating James Webb's launch its life from a tropical rainforest, and we were going to a faraway place that no astronomical instrument had ever gone before, in this case to the edge of time. And so I blended those two elements together for the liftoff line. And I must tell you that, not to break my arm patting myself on the back, but I have never gotten so much email from around the world for a broadcast in my life.
Decollage liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
And those words have gone really quite literally round the world. I'm going to just skip this one now because we have a little, hang on, I'm just going to, okay. Just thought you might be interested as well because Rob Navius, he was commentating for a radio station during the Challenger disaster. So you can just imagine if you're live on air, this is one of the things about live television and live radio, you have to say something. But you know, you have to be very considered and thoughtful about what you say. So he told me about how he approached that terrible disaster.
I'm watching the launch out of my left eye, and I could see Challenger lift off and clear the launch tower, and then it was out of my sight. Now, our writers in the front could still see the vehicle. I could no longer see the vehicle with my own eyes, so I was relying on television. And suddenly I saw this flash peripherally out of my left eye, and I looked over, and you could see the spreading cloud and the debris, and you could hear the commentator in Mission Control, Steve Nesbitt, who would say, who said there was a pause, and I looked over and I said something on the air that, had I been wrong, it would have been the end of my career, but instinctively, I just knew that I was right. And what I said was, wait a minute, I think there's been an explosion. Is that possible? Without any data, just looking at what had happened and being familiar with the ascent profile of a space shuttle. And then, of course, you saw the solid rocket boosters fly away in a wild, divergent manner, and you knew that something horrible had happened. And then Steve Nesbitt, who was the public affairs officer in Mission Control, he said on the NASA TV channels, he said, there's been a major malfunction. The vehicle has exploded. And for the next several hours, I was on the air continuously with no particular information to report other than to recap what I had seen and what we knew at that time. And then, of course, the information began to unfold later in the day in a rather dramatic and tragic fashion, that the crew, in fact, had been lost. And, it was very clear that the space program was going on hold.
So you, we were talking earlier about how you go into broadcasting. As I said, there's sort of traditional routes and doing media courses and that sort of thing. I'm not sure really how helpful a media course is, if I'm truthfully honest. I think if you are going to do one, I think it's worth doing something very, very vocational, as I said earlier. And also, it's really kind of good to do your own things. Podcasts are a great way of starting because you don't have to worry about what you're seeing. All you have to worry about is what you're saying and how you tell your story. You still need to get lots of sound effects and tell your story in an entertaining way. It's not easier, it's just a little bit different. So I was thinking, I'm just going to do a quick fly through here because if I was thinking you might, if for anyone who is going to make their own little films on their camera, which is a good way to start. You can start by sort of practicing commentaries and things, take rocket launches and things that have already happened, and you can practice those on doing your own commentary at home. I'm going to skip that slide for a second. Well, just quickly, if you're going to get ingredients for your little shows, your films, you've got your stock footage, you can get that from the space agencies and the animations and interviews and that sort of thing. Then you'll be doing your own filming, etc. You can get your stock footage from a range of websites, and then things like European Southern Observatory. You go on their websites; they've got images of stars and stuff that the telescopes in Chile are looking at, and you can obviously do your own filming as well. And I just thought we'd have a few little tips. If you are going to film, remember, your eyes do not see the world in a frame like that. So make sure you hold your camera in landscape. Turn yourself into a human tripod. Hold your camera very, very steady with your feet planted on the ground. Do not make wobbly vision. So keep your pans and your tilts nice and smooth if you do, and slow. Remember, really it's easier just to take lots of short still frames, to be honest, and count to 8. Your shots need to be long enough for you to be able to edit them afterwards. And always start filming somebody before you interview them, not when they're about to start talking, just so that you've got a little bit of a run-in. Remember to get lots of different shots. You can shoot this room from the wide angle. I can shoot you all from lots of close-ups. And make sure that you break down the action. So sound is just as important as pictures. If you've interviewed someone but you can't hear them, it's unusable. So if you are interviewing someone, make sure you get close if you're using the microphone on your camera, and if you can put a little clip mic on them like this, then that's even better, because then they can walk around. And listen out for all the noises around you, and if you are interviewing somebody, make sure you get the music turned off. Also, light is your friend. Stand in front of the light. Not the light behind you for obvious reasons. And practice makes perfect. Keep on making your little films. Keep doing it and shoot little sequences. Shoot someone getting into a car, for example. What do you need? A wide shot of them opening the door and getting in. You might get a close-up of their eyes in the wing mirror. You might get a close-up of the key going into the lock. Watch television and look at all the little shots that they've made to make a sequence. You need a lot of different shots to turn something into a sort of 5 seconds of television. But the problem with space is it's in space. So how do you film it? Well, somebody who's going to be talking after me is a bit of an expert on this. So you're very lucky devils. But if you don't have enough footage, you have to talk to the camera yourself, or you get somebody else to do it. Now, if you're fronting something and you're explaining things in front of the camera, there are lots of things you need to think about. Obviously, you know, as I said, make sure you've got a nice light source, make sure it sounds good. Be yourself. And I know that sounds like be yourself. But it's true. It's very, very difficult when you're standing in front of a camera to actually be yourself. You suddenly find yourself being somebody different to who you really are. So you can practice being yourself in the mirror. When you, think about how do I actually look when I really genuinely talk to my friends, and try to remember that and try to bring that into your presenting. And also think outside the box. So as I said, space is in space. So apart from animations, we really have to film space on Earth. So you have to rely on the things around you. And unless you've got a Brian Cox style budget, you're going to have to think about what's in your kitchen, what's in your lab, and how you bring your messages to life, but also how you take very complex ideas that you're working with and how you turn those into something nice and simple that people can understand. And I would like to show you one of the women who I've been working with at NASA, Sophie Roberts. She works for NASA and she makes a lot of films for NASA. She's actually, I think she did a science, just as an aside, talking about going into the media, I think NASA runs some very, very interesting programs that you might want to be looking into. Not NASA, in the US. Do you know what? If anyone has any questions about this, ask me afterwards, because I'll have to get back in touch with Sophie. But she was telling me she did a very fascinating program. So she comes from a science background, but which taught her how to do broadcasting, how to make films. And she then got jobs. She's worked with the Smithsonian. She's fascinated also with biology, and then she started working with NASA. So that could be an interesting way in for you guys. And I'm going to be hanging around here this afternoon, so do come and ask me, or I'll put my email address on at the end, and you can just ping me an email. So let's watch Sophia's. So this is her, right, taking a really difficult, not necessarily a difficult concept, but explaining some science, and she's just thought about what's in my kitchen. Well, how can I explain this?
Attempt to make something that is really vital for the Webb telescope's ability to see. So let's give it a go.
So just wind it back to the beginning.
Attempt to make something that is really vital for the Webb telescope's ability to see. So let's give it a go. But first, I have to make some distilled water. See that? Very cool. Let's get it done in the kitchen. It's a salt crystal.
Who doesn't love salt? It has a long and important history. Since it was once the only way to preserve food, it also dictated trade routes. It was one of the most coveted and expensive minerals. Today, we rely heavily on salt to keep our roads safe, and salty snacks are the best.
Webb needs salt. Not this tasty kind, but as a lens. So there are different types of lenses. Mirrors are a reflective lens that bend the light. And then there are transmissive lenses that allow light to pass through them. Here's the kicker. Visible light, it behaves differently than infrared light. So glass absorbs infrared light, but salt doesn't. The type of salt in here is sodium chloride, or NaCl, and even though it's the most common type of salt on Earth, it is not the only kind.
Salts are more than something you sprinkle on your food. A salt is a combination of two things: a positively charged element, usually a metal, from groups 1 or 2, and a negatively charged halide, usually from groups 16 or 17. They get their charge by either gaining or losing a negatively charged electron. So Webb uses 3 kinds of salt lenses: lithium fluoride, barium fluoride, and zinc selenide.
So making these lenses happens to be pretty tricky. I've been growing this one now for about 3 weeks, and it's only this size right here. The lithium fluoride lenses that Webb uses have to be absolutely perfectly grown. So to be optically useful, it needs to be completely clear, unlike my homegrown little crystal over here, and be molecularly consistent. That means that the structure of the molecules are absolutely the same everywhere. Then they have to be cut, and then they have to be polished. Considering what these lenses will do, they are sure worth their weight in salt.
So I just love how she's thought about things. She's thought about the sound. You could hear the sound of the crunching of the salt. The crisps. She's filmed the crisps from. She's filmed the salt. She's put a camera underneath the things. You could see the salt falling on top of the table. You could see her hand going inside a crisp packet. There are lots of different ingredients to make it interesting. So well, do you know what? I know that we are now running out of time. And I know that we've been running late. So I did have a few other things to talk about, but actually I'm just wondering whether we wind up now and make that the last message. So if you are going to be making your own films, and if you are going to be in front of the camera, make sure you think outside the box and think of nice, simple ways. You know, Brian Cox, he'll describe something like entropy, and he'll be on a beach and he'll be using sand and a sand castle, you know, to show how it works. So these are things that you can think about in your day. How can I explain this in a nice, simple way? My email address is down there, so I will go back to Sophia and ask her about the course that she did, because I think it might have been for scientists, but I can't quite be certain about that. And if you do have any questions about that, please let me know. And also, if anybody wants to do, I work alongside a cameraman who does workshops on how to film and edit your own film on your phone. So if anyone was interested in doing a one-day workshop, and I sort of teach the presenting side of it and he teaches the technical side of it, so if anyone's interested, please just drop me a line. So there we go. Does anyone have any questions? Or thank you.
Hello, everyone. Okay, we're about to start. So, coming up now is Chris Riley, an award-winning writer and filmmaker who is particularly interested in science, engineering, and history. You may know him from his documentary films such as First Orbit and In the Shadow of the Moon. Today, he's giving us a talk on various of his space-related endeavors. Let's welcome him.
Thank you. Thank you, Pedro. Thanks very much for the introduction. And it's really lovely to be in a room with people rather than shouting down a Zoom camera, as we've all been doing for a couple of years now. So thank you for inviting me. It's lovely to be back here. So as you heard in the introduction, I'm a writer and filmmaker. I mostly make films, but filmmaking is largely writing. And I'm writing a film for Disney and National Geographic at the moment, which is a big writing job, and it is all writing until you know what your story is and you've worked that out, and then you go out and shoot, which I'll be doing in another month. But there's no point going out and filming until you know your story, so there's a lot of writing. People sometimes say I make films about space, but, and I know this is probably a bad thing to say at this conference, I'm really not interested in space. There isn't anything to make a story about in space. I make films and tell stories about people. And all my films are about people. It just happens that some of those people live and work in space. Some of them make things that tell us more about our universe. And that's where the limit of my interest in space is. I did a PhD in planetary science here in London at Imperial College, and then got my first jobs, much like Katy was saying, in radio, first of all, learning how to tell stories with characters that you believed in and cared about. And then I graduated into television, spent 10 years at the BBC, and a further more than a decade now outside the BBC, working for Channel 4, HBO, the Smithsonian, Netflix, Amazon sometimes, and National Geographic, which is owned by Disney these days. So back in 2017, I was asked to join the writing directing team on a big new series that National Geographic was planning called One Strange Rock. I don't know if anybody's seen it. Anyone heard of One Strange Rock? A few people. Well, so One Strange Rock was part of National Geographic's kind of rebranding. They'd been around for a long time and had largely been sort of chasing the lowest common denominator in their cable documentaries. And they wanted to do something a bit more ambitious and bold and more distinctive that was more in tune with the values of their magazine and the society. And so we were sort of charged with this challenge of making this big 10-part series about Earth science, really, partly space science as well because it's related. But we couldn't really call it an Earth science series because that's a bit of a sort of turn-off, hence the title One Strange Rock. We decided to theme these episodes around a story of life on Earth. And really, this is a story of how incredibly unlikely it is that we should be sitting here as sentient beings in this room right now, when you look at the twists and turns of cosmic serendipity that led us to be here today. And in the series, that was going to be reflected as these sort of themed groups of episodes, ranging from how our atmosphere emerged on Earth and became a breathable atmosphere with oxygen, the chaos and confusion that reigned in the planetary disk around our star when our planet first emerged with a particular chemistry in the Goldilocks zone. The further unlikely prospects of these various shields being baked into the Earth, from the ozone shield to the magnetosphere. And then how, in episode 4, how life started to change and altered the Earth's chemistry in itself and affected the biosphere in profound ways. Those 3 Living Planet programs then were going to be largely reflecting on this emergence from chemistry to biology, emergence of life, and then the rise of complexity, how life became so complex, again, really against the odds, right the way through to consciousness emerging. My episode that I was going to be making was the 8th one in the series, called Survival, which was largely about the role that death and sex have on shaping Earth's life story. There was another episode then on the emergence of this opportunity technologically to perhaps leave our planet one day, and a last episode reflecting quite philosophically on what it means to call this planet our home. So let me play you a trailer just to give you a flavour of our ambition.
Everything out there.
Somehow, a big rock came alive.
So as you got a glimpse of there, the series, and the conceit of it really was that it would be hosted by a cast of astronauts, people who'd left the Earth and looked back down on it and had that overall greater sort of view and perspective. We looked at over 300 astronauts when we were trying to cast this series. We were particularly interested in the range of disciplines that they had. I mean, these days, often you don't find too many career astronauts. Instead, they're mission specialists that have a background in medicine or engineering or life sciences or earth sciences or astronomy and physics. And we really wanted to reflect that in the casting of the series so that they could talk with authority about these topics and story arcs that we were crafting. Of those 300, we then got show reels together, we had lots of phone interviews. It was a funny process in a way, getting these astronauts in a sense to apply for the job. So we had all these Zoom calls with them where we'd ask them lots of questions, try and get them to kind of communicate to us. And then we'd show all of those kind of calls, those video calls to the channel, and together we'd come to a decision about them. But obviously we did have to reject quite a few out of 300 to get to this 8. Peggy in the bottom right, Peggy Whitson, was somewhat self-selecting because she was going to be flying on the station during the period we were in production. And we obviously couldn't kind of change who was on orbit when we were filming. More of her in a moment. Drawing all their stories together then was a big Hollywood megastar, Will Smith, who came on board quite late on in the project, but was really useful for a couple of reasons. Firstly, he kind of we were able to write commentary for him to kind of link everything without reverting to this kind of voice of God figure. It was a person there that could talk to us. I'm just going to dim the lights a bit on him. And secondly, he has an enormous, multi-million count and higher sort of following on social media, which brought another audience to the series that might otherwise not have noticed it. Our other key collaborator on this was the filmmaker Darren Aronofsky, who's there in the middle next to Mae Jemison. And he, some of you might be familiar with his work, has a very particular artistic style that he brings as a director to his films. So we, working with him, we took his canon of work and sort of dissected it really meticulously and came up with our own Bible for the series. I've rarely worked on a series, actually, where you end up with a very big sort of shooting Bible that gives you a sort of set of instructions as when you go out, how you're going to film something. Often you're left to your own devices to storyboard and work out what kind of cameras and lenses and lighting you want to use. But in this case, we were really keen that we honoured the Aronofsky sort of brand, as it were, in trying to achieve this series. For those of you who don't know his work, it's quite quirky and odd at times, but it's visually very captivating. He's very interested in extreme close-ups. He particularly loves filming people's eyes. And so that was part of what we looked at doing. He also often has his characters moving through the scenes that they're part of with these dramatic following shots that lead you behind. But we worked very carefully to make sure that we were really loyal to that as well, with exactly the right lenses and f-stops and aperture settings and the distance between us and our contributors when we were sort of traveling through various spaces around the planet with them as well. We even went as far as working out the direction that the drones should rotate as they rose vertically above the landscapes that we were filming, so it was always clockwise. So armed with those Bibles then, we set out across the world to shoot this. As I said earlier, my episode was about the roles that death and sex have played in shaping life on Earth, and the astronaut that I picked initially actually to film with wasn't Jerry Linenger here on Mir. It was actually Pierce Sellers, who I spent a year working with, the British-born astronaut. He was running the Goddard Spaceflight Centre science teams at that time, but he was also suffering from cancer. And very sadly, after about a year, he died, I think thankfully just before Donald Trump was elected, actually, who largely did a lot of damage to the work he was doing. Anyway, so I had to begin again, and Jerry was by no means a second choice here. He was a wonderful man that was on the list from the start, and a remarkable storyteller in his own right, and had a hell of a time up on Mir when a fire broke out and nearly killed them all. And the reason for, obviously, filming with him for this episode was because it was about death. He'd confronted death really viscerally. At one point during the fire, he was suffocating and he couldn't find a mask, and he closed his eyes and he said goodbye. And he tells that story in the film very powerfully. If you think about it, and I really hadn't, I mean, I am an earth scientist, but I'm not a life scientist. But without death, you have no Darwinian evolution. Death is the sculptor that sculpts the stone that life is made of and shapes it. And so this film became a story about how death wasn't always there. Programmed cell death in early life wasn't even a thing, really. Cells would just kind of go on forever and sort of just clone themselves. And so death emerges in this story and is largely a trade-off on Earth for complexity, because evolution has sort of dictated that actually, if you're a really complex organism, it's better to live fast, reproduce young, and die quickly, rather than constantly trying to patch yourself up. And that's really what's behind this Cambrian explosion of life 600 or so million years ago that we're the product of. So I got to travel all over the world, Tanzania to the Maldives there, filming something about parrotfish. That was for another episode. And in the bottom right, filming with meerkats in the Karoo Basin in South Africa, where the Permo-Triassic mass extinction beds are beautifully exposed. This was the largest mass extinction in Earth's history, 252 million years ago, where something like 96% of life on Earth disappears pretty fast, largely due to climate change. Of course, the survivors of that mass extinction, we are the descendants from. And many of the early proto-mammals were a little bit like meerkats, those that survived underground in burrows. And so we filmed a very elaborate scene in the Karoo and in studios with them in burrows we built to illustrate that point. One of the other locations I went to, which is in all our hearts at the moment, is the Ukraine, where I filmed at Chernobyl, the Chernobyl reactor, for a story about mutations and the effect that radiation has on evolution. I'm the one that's, I'm second from the left, so I'm not the shortest there. With a very, very tall director of photography, DOP, who's a specialist in filming insects. We were interested in the spider webs that another researcher had been studying there. The spiders most affected by radiation in Chernobyl weave very strange webs that their sort of architecture has been modified by the radiation. It's an interesting story. My other job on this series was producing all the sequences on the International Space Station, and I had some form in in this area from previous projects, which I'll come on to in a bit. There are a lot of challenges working to create a film on board the ISS, not least that it's a big international laboratory, so you have to have all the kind of partners on board, and then there's equipment that's up there that you've got to work within the realms of. So there's a huge camera team at NASA that run all the inventory of lenses and lights and camera bodies. Camera bodies don't last very long in Earth orbit because the CCD chips get fried quite quickly. So within weeks of getting there, you end up with dead pixels on the CCDs. And if you leave them up there long enough, they become really irritating and unusable. So they do have to renew the camera bodies periodically. So we had two choices. Could we fly our own equipment up there, or should we kind of work with their camera gear? If you've got the budget and the time, you can fly your own gear up there. It costs something around $250,000 to rate a camera for spaceflight. And you're often talking about a camera that's a few £1,000, and you've got to spend £250,000 to rate it. And that's because it's important it doesn't set fire to anything up there. So they have to do a whole battery of tests on the batteries and other parts of the camera to ensure that it's definitely not going to cause them any problems up there. We had a big budget, something like $30 million to make this series, but we didn't have enough to kind of get our own cameras flown up there. So we worked with them within their boundaries to work with their camera gear. They largely shoot on Red cameras, that's the brand. So we trained our DOP, who's Paolo Nespoli, an Italian astronaut, at a facility just outside Rome here before he went up. He already knew how to use the camera. He's a really accomplished photographer. In fact, I don't know if any of you know the scenes of one of the last space shuttles docked to the International Space Station. That there's very few pictures of it that have ever been taken of the shuttle docked from outside. And Paolo took all those photographs as he was leaving on one of the Soyuz capsules. And they practiced that whole photography mission for over a year, trying to work out the logistics of it. He had to unbuckle himself and float into another part of the spacecraft and unstow the camera and go to the window. And he's very tall, not ideally suited for Soyuz travel. And so they rehearsed the heck out of this operation. So he's very familiar with cameras and so on. So importantly, though, for us, we were careful to storyboard this. The time up there is, thousands and thousands of dollars a second that it's costing to keep them alive away from Earth, working up there. And time is really tight. Their schedules, their timelines are often like double or triple booked, where they're running multiple experiments at the same time. And then throwing media requests and opportunities in on top of that is often really challenging. So we went and spent a day filming with him. We had a Zoom call with Darren Aronofsky from New York and went through all of the shot lists and storyboards and tried to give him a quick sort of Aronofsky kind of crash course on cinematography, the very tight macro shots and the big wides and the camera moves that we were striving for. Just before I play you a clip of what he shot, his mission going up there was really to film Peggy. So he overlapped with Peggy by a few weeks. And we had this story that we'd written of Peggy living on board the space station that would be in episode 10, Home. And Paolo agreed to then sort of film it to our sort of instructions up there. He left, I seem to remember, sometime in the early summer of 2017. And I went on holiday, actually. I was off in the States for a big eclipse that was happening, a solar eclipse out there with my family. And we were on a road trip getting towards the eclipse. And the phone suddenly rang, and it was Paolo from the space station on my mobile. I pulled over. I said, "You all right?" And he was calling because he was having trouble with the camera. He was really stuck, actually. And although they have their own technical teams, obviously, back on Earth, some things they have to solve themselves. And so I pulled over, found a diner, sat down, pulled up all the camera manuals myself and went through and tried to troubleshoot it with him. And we had to kind of compromise in the end. He couldn't essentially change the f-stop on it. It was set in some auto mode that meant everything was very overexposed. So we really sort of struggled for a few hours together. And he went away and we carried on sort of emailing each other, emailed him advice and stuff. It felt a bit surreal, I have to say, sitting there in California where I was, trying to kind of help him fix a camera up in orbit on my mobile phone. Anyway, I'm pleased to say it all worked out, and so I want to show you the opening of episode 10, which is all shot in orbit by Paolo.
Where is home? Is it where you were born? Where you were raised? Or where you are now? Is it somewhere you live? Somewhere you left? Somewhere that shaped you? If you really want to know, you need to leave them all behind. Someone who knows what it's like to really leave home is Peggy Whitson, NASA's most experienced astronaut. Not that you'd know it if you ever met her.
Oh, I hate talking about the records, but I do have a few.
That, folks, is the understatement of the year. How about we start with most time in space for any US astronaut?
Which is 665 days.
Think about that for a second. That's a round trip to Mars. Then there's the longest single space flight for any woman in the world.
Oh, that's right, yeah.
And that's just for starters.
10 spacewalks, first female commander, and I don't remember any others. Oh, I'm the oldest astronaut, female astronaut. Not a record I was looking for. The press seemed to point that one out a lot.
Not bad for a farm girl from Iowa. Eight astronauts: Chris, Nicole, Jeff, May, Jerry, Mike, Leland. And then there's Peggy. Each one of them is different. They come from different places. They have different stories to tell. But they were all changed by one thing: going into space. It's called the overview effect. And if you could see what they've seen, you'd feel it too.
The series is still on Disney Plus if you are interested in seeing the rest of them. I wanted to move on to another project I did. In 2003, I was producing a big drama for the BBC called Space Odyssey. It was made by the team that had done Walking with Dinosaurs, and they kind of figured, well, what else are kids interested in? Well, space. It wasn't made for kids, actually, but it was the same team. And so we spent about 2 years working very hard on this, filming all over the world and trying to tell the story of a fictional human mission to the planets. Our rule with this was that we couldn't break any laws of physics. So in fact, I spent 3 months at the start trying to actually work out a mission without moving any planetary orbit so that we could kind of visit all the planets in meaningful amounts of time with a fictional engine, but still one that was possible in terms of physics. And so it was very laboured, the work, but a labour of love, I think. And one part of it that was really important was that we had an astronaut on board with the series to advise the actors. And when I'd previously been at the BBC, I'd met a medical doctor for an ear study I had to have done for a parabolic flight. I was working for Tomorrow's World at the time. And this doctor, I remember him saying to me, he said, he knew I was interested in Apollo, and he said, oh, you know, one of the Apollo astronauts is living here in London at the moment. That's Dave Scott, the commander of Apollo 15. And I didn't know. He was living down the road in Chiswick in West London. But I kept this doctor's number, and when I started work on Space Odyssey, I phoned up the doctor and I said, you couldn't ask Dave if he might be interested in coming and working on this series with me, could you? And within an hour, Dave phoned me up. He just finished working a few years before with Ron Howard on Apollo 13, and he made the HBO miniseries From the Earth to the Moon with Tom Hanks, and he was here in London for a few years and looking for other media projects to get involved in. So we met up and became good friends. And he came along to all the shoots. So here he is on the right-hand side there in Pinewood Studios, watching the monitors and giving notes to the actors as they're trying to land on various rocky bodies around the solar system. And it was such a sort of treat to have him there. Someone who spent 3 days living on the moon, drove the first electric vehicle through the mountains of the moon, and here he was telling them how to do it in our story. When we finished this project, after a couple of years, we went out for dinner. We'd often go for dinner, actually, in a pub called the Dove on the side of the river near Hammersmith, on the riverbank near Hammersmith. And he'd always have the same food there. He loved fish and chips with tartar sauce. And we had one rule when we met with Dave, which was don't talk about the moon, because he spends his whole life, whenever he's in public, talking about the moon, and that's the last thing he wants to talk about. So we talked about everything other than the moon with him. He's a great aviator, has amazing stories of flight. And he said at this dinner, when we went out after we'd finished Space Odyssey, he said, look, I'm thinking of an idea here where we get everyone who was someone from each of the Apollo missions that landed there in a room together, one day only, and we film it, make a film out of it. What do you think? You know, just them sort of talking at a lectern like this. And we said, well, it's a lovely idea to sort of celebrate Apollo. Of course, lots of documentaries out there already. But we're not sure that a bunch of you all standing at a lectern talking is sort of going to be compelling enough. We need to sell this to a channel and raise some money. And we said, look, come and see this film with us. I'd urge you to go and watch it if you haven't ever seen it. You can stream it these days. Touching the Void. It's the story of a climbing accident that goes very badly wrong. Made quite a few years ago now, but it really changed the face of documentary making. Brilliant interviews and reconstruction. And we said, we went to the cinema with him, took him to dinner afterwards again, and said, why don't we do for Apollo what Touching the Void did for that climbing film? We don't need to refilm any of it because you guys shot all that footage as something 13.5 hours of flight film from Apollo, which I'll mention in a moment. And then we just do these long, detailed interviews with you guys and pull it all together into a single story. And he thought about it for a while, and a few more fish and chips later, he kind of agreed to kind of support us. And this became the Ron Howard film In the Shadow of the Moon, which I was one of the producers on. And so the challenge that we really had with this, I'm just going to dim the lights a bit more so you can see the slides a bit better. The challenge we really had sitting down with all the Apollo astronauts was that actually this is a bunch of people that's very, very interviewed. Many of them, including Buzz, have been interviewed maybe tens of thousands of times, and they're sick of telling their story really often. It's just like putting a record back on and playing it again. And we didn't want them to do that. It was important to us that they thought about the answers that they were going to give. So we researched the heck out of these people, and any of you who are interested in going into filmmaking like this, the trick with interviewing is to do your homework. So we spent months pulling together everything we could find on each one of these people. We read every single book written by them or about them. We downloaded every PDF we could find. It was the days before podcasts, but we tracked down radio recordings whenever they'd spoken. Every single word they'd said publicly, we tried to find, to dissect who they were. We had 100-page dossiers on each of them. The night before the interviews, we'd march around our hotel rooms, I remember doing this, and learn like we were cramming for an exam. Because the last thing you want to do when you're interviewing someone is hold a set of notes up and keep kind of referring to them. You want to lock eyes with someone and talk to them. And that was the job here. We had to learn their lives, to know their lives better than they did. Then we stick our papers under our chair and talk to them for a couple of hours about their lives. And we took them to places they'd not thought about before, relationships they've had with their children, their families, the toll it took on them, and all this stuff, and made them really think. That was the secret. We were funded at this point by Channel 4, who were mildly interested in the project, I would say, not very committed to it. but thought it would be a nice kind of 1 hour to go out at 11 o'clock one night on the channel. Principally because we said we were confident we could get Neil Armstrong in the film. Dave Scott had flown with him on Gemini 8, they were good friends still, but the problem was Neil in those days was really pleased not to be recognised. He spent decades after he came back with his life somewhat ruined by stalkers and weirdos, and he didn't want that to happen again, and so he was pleased to be able to queue up for an internal flight in America and no one would bother him because they didn't know it was Neil Armstrong. And that was good, and that was how it should be. And we didn't push him on it. We weren't trying to sort of hound him or anything. And he was very supportive. He emailed us occasionally. And when an email from Neil Armstrong arrives in your inbox, it's like getting an email from the Archangel Gabriel. It's quite a day. Now, the archive, which I'm something of a specialist on, there's 10,000 rolls of 16mm film that NASA shot between 1958 and 1972. It's scattered across various sites in America, the various NASA facilities. The bulk of it, however, is at the Johnson Space Centre in Houston, Texas. And we went and looked through all 10,000 rolls on paper, pulled out about 1,000 rolls, and some of them hand-cranked them through these viewers, looking for the right shots that we were after. This body of work was so deep that you could approach it like a film director. You could sort of almost storyboard it in your head based on the interviews and, okay, I need a shot of Dave Scott leaving a building about 1967, walking out with someone else and getting in a car, and you could find that shot. It's very well archived on paper. I think we were one of the first filmmaking teams to go through this archive, actually. A lot of people have done it since, but these rooms were super cold. We were locked in them all day, and you come out in a lot of pain at the end of the day. I lost my eyesight doing this job, actually. I have to wear glasses after this. What we found, though, in that treasure trove were the most amazing bits of footage of these men as they were 40 years before. And what you noticed very quickly in comparing them as they are today, when we've shot this with them as they were then, is that they had the same mannerisms. They would have the same tics, and they'd look down and look up and look in the same way. And, of course, their faces were just aged but the same. And we were able to kind of intercut them today as they were when we interviewed them and as they were then in this beautiful way that sort of danced delicately back and forward between time. There's one, as I mentioned earlier, really important body of this film, which is about 13 and a half hours of flight film, as it's called. This is footage that was loaded onto the spacecraft and shot in orbit and on the way to the moon and on the surface of the moon. This footage is so precious, it's all in 16mm film, that it's stored under liquid nitrogen in Texas, in vaults there. And they only bring it out occasionally when they have a new format to transfer it onto, which was the case here because high definition was just emerging when we made this. So we got all of that film out and had it tele-cinied up near Chicago. It's shot actually on this camera, a Moore 16mm. It's called a DAC, a data acquisition camera. This footage was not shot for us. It was not shot for documentary makers. It's obviously been used a lot by them since. It was shot for engineering reasons. They would lock the cameras off and film when certain maneuvers were happening, or dockings or undockings, and it was a record of what happened in case anything went wrong. They used it to make some of their own home movies, as Bill Anders is showing you here on Apollo 8, and Apollo 7 below there, but it was really for engineering purposes, but it made a great body of archive for us to use as well. So I'm going to show you a clip featuring some of that film of some of the astronauts reminiscing about them leaving Earth.
Earth orbit, the horizon is just slightly curved. When you head on out to the moon in very short order, and you get a chance to look back at the Earth, that horizon slowly curves around and upon itself, and all of a sudden you're looking at something that is very strange, but that is very, very familiar, because you're beginning to see the Earth evolve.
I was able to look out the window to see this incredible sight of the whole circle of the Earth. Oceans were crystal blue, the land was brown, and the clouds and the snow were pure white, and that jewel of Earth was just hung up in the blackness of space. The only people that have seen the whole circle of the Earth are the 24 guys that went to the moon.
When you see Earth like that, it's powerful. Not any bigger than that, way up there.
How peaceful and calm and quiet and serene it looked. How fragile it appeared. That was oddly enough, the overriding sensation I got looking at the Earth was, my God, that little thing is so fragile out there.
You get to see the Earth receding, you get to see the moon coming towards you, and it's awe-inspiring. And to start to identify, hey, we're going to be up there pretty soon, and bye-bye back there.
The music was composed by a composer called Philip Shepherd, a really talented man, and I still collaborate with him today. We took an early cut of this film then to Channel 4 to show them, as you've got to do, because they bankrolled it. And after about 15 minutes, they stopped it, they hated it, and we were thrown out of the building. Looking back, I think it was because the trouble with broadcasters is they terrified the whole time. And all they have to go on really is how the audience figures looked the night before. And I think probably the night before there was a film about some old men reminiscing with a bit of archive that didn't do very well for them. And this email had gone out that morning saying, no more old men and archive commissions. And that's what we made for them, because that's what this story is. You know, nothing wrong in that. Anyway, the other producer and I went and sat in the South Bank just out here and watched people selling the big issue. We'd spent all the money by then. We thought our careers were over. But possession is 9/10 of the law, and we kept hold of the material and carried on editing it in our own time, and were introduced to the director of the Sundance Film Festival, in fact, that summer. And we told him about the project, and he said, well, it sounds interesting, do keep in touch. The Sundance Film Festival takes something like 1 in 10,000 submissions, so it's quite unlikely that you get your film in there. Anyway, we sent them a further cut nearer Christmas that year, and they said, that's great, we'd love to have it. And so we premiered it at Sundance. It won the World Cinema Audience Award there and went on to get longlisted for an Oscar. And Channel 4 then said, oh, hang on a minute, maybe we should have another look at this film. And came to the various premieres that we did, including a lovely one in New York at the Natural History Museum with the astronauts. And so it all kind of worked out in the end. I wanted to tell you a bit then about a very different kind of project that emerged after that. I started taking some of the flight film, that 13.5 hours of flight film, and projecting it all unedited into gallery spaces around the world. It was a show I called Apollo Raw and Uncut, and it still sometimes plays in various venues around the place. What I loved about it was that it sort of exposed you to the absolute unedited raw rushes from the camera in leaders to the camera out. I ordered it chronologically pretty much, so it gave you these journeys up and down to the moon 9 times as America went there in the 1960s and 70s. It was around this time, though, I started thinking about another big spaceflight anniversary that I wanted to try and celebrate with another kind of installation, and that was the 50th anniversary of the first human being to orbit the Earth, Major Yuri Alexeyevich Gagarin. If you Google his route, you'll see that he left from Kazakhstan at 6:07 in the morning and headed over Siberia. This is in April, obviously. It's covered in snow. He crosses into the night side of the Earth over the Pacific and travels down, not much to see there, night side of the Pacific, Pacific of the Earth, and then comes back up again just south of South America, just north of the Antarctic Peninsula, and then he crosses into this dawn light, this beautiful dawn light over the South Atlantic, travels right across the African continent, over the Mediterranean when his re-entry program starts, and then he, as many of you are aware, has to kick the door open and sort of parachute out. I think actually there were explosive bolts that throw him out. Anyway, he came down on a parachute, and the thing was, there was no footage of this. They didn't film it. They had a camera pointing at him that was really just there to check he was still alive, and it disappeared after he went into Siberia. So I thought, could we film his route on the International Space Station. The Italian Space Agency had just put this cupola on board, that you're familiar with, I'm sure. Tracy Caldwell Dyson there, as an astronaut, admiring the view of Earth from it. And I thought, could we film it again? So I needed to, first of all, start. It's the only film I've made that started with a maths problem, where I had to match the orbits of Vostok 1 with the orbital elements of the ISS. And I'm no mathematician, so I called up the European Space Agency and asked if they might be interested in playing around with this. And they were delighted, very interested, very accommodating, lovely team to collaborate with. And we worked out that we could just about match Vostok 1's orbit in segments over the course of about a 6-week cycle, because it was important. It was the time of day he went over that ground had to be the same time of day I was filming, so it took a while to match it up. So over the course of that 6-week block, we were able to film that again. As I talked about before with cameras and the cupola, the windows are all numbered, and I storyboarded the whole thing to work out which window I wanted filmed out of at which time and how long to leave the cameras locked off for. And again, Paolo Nespoli, completely coincidentally, this was before the One Strange Rock project, was available to do this. So he helped me, and here he is on board at that time filming some of it. What I started to realize, though, that this was becoming sort of bigger than I'd expected it to be, and I was just going to stick it in a gallery somewhere. And I thought, no, there's something bigger to do here. So I teamed up with Yuri's Night. Some of you might know about Yuri's Night, which is a sort of global celebration of this moment in human history, which is held all over the world every year. And I tried to get them on board to sort of screen it as a sort of premiere, a global sort of premiere. And in the end, we managed to put it out on 1,600 screens in 130 countries, including the BBC City Centre screens here, which caught the attention of commuters all over the UK that day. And we showed it to the second, 50 years after he'd made this flight. I was introduced to Google and YouTube around this time as well, and they loved the idea. They said it was very googly, whatever that meant, but they really liked it. And so they helped me create this First Orbit channel, and we premiered it at the same time of day, 50 years later, on YouTube. And they linked to it through their Google that day, and it became the most watched long-form film release in YouTube history. There weren't many long-form films on YouTube at that time. It was mostly short-form cats on skateboards and things. But this really caught people's attention and was a big hit and still sitting up there. I urge you, if you want to still watch it, it's on YouTube and you can stream it any time. When you get to the Pacific, it's pretty trippy because it's night vision cameras for about half an hour in total darkness. And there's the odd flash of lightning and stuff, and you can see the moon. I tried to make something of the constellations, but you start hallucinating after about 20 minutes. So maybe that's a good thing. I just want to move on to another very different project that I tried to do this year and last year to kind of connect people with Mars and to draw attention to climate change. My first job at the BBC had been on a show called Mars to Clive Anderson in the 1990s. It was there to mark Pathfinder touching down as airbags, the first bounce down onto Mars in 1997. And people kept coming up to me. I was the researcher on it. People kept coming up to me and asking, what's the time on Mars? Which is a completely meaningless question. What they meant was, what's the time at the landing site? But this was the problem I kept encountering, that people thought of Mars as just a place like London or something. And so whenever you get like pictures of Mars coming back, you know, and I talk to friends about it, they just say, oh yes, that's Mars, is just red, isn't it? And that was it. There was no thought about the differences in these different parts of Mars and how the landing sites differed. My PhD was in geomorphology, and so for me, I can see, you know, radical differences in these pictures, but they just couldn't. So I started thinking, how can I draw attention to the fact Mars is a whole planet like the Earth is? And I came up with this idea of maybe mapping the existing landing sites back onto the Earth. The question was, what were the Martian coordinate systems? Well, it turned out in 1832, two German astronomers called Wilhelm Beer and Johann Heinrich Madler had come up with a coordinate system based on a meridian mark going through Sinus Meridiani in the center there, that blob in the center. And Giovanni Schiaparelli adopted their system and created his maps out of it, so it really caught on. And then, of course, NASA went on to use the same latitude and longitude system for their missions here. So I started mapping them onto Earth to see what this would do. It was just an experiment, really. Sure enough, you can see them there. Some of them are into big ocean basins, some of them on the continents. And then I started looking for photographs of these places to illustrate it. So there we've got Vikings, Pathfinder, Spirit in the Columbia Hills, and Opportunity, same there, Phoenix, Curiosity, and Insight. Now, when you stick them together with these Earth images, actually 5 of them map onto the big ocean basins, and they're not very interesting. It's just flat. It's wet, I grant you that, but there is not really any sign of life in those 5 pictures. Same on Mars, of course. The other 3 map onto river basins, some of these big river basins in other parts of the world. But again, they don't really show much in the way of life. There's a bit of plant life in a couple of them, but certainly no animals. And more staggeringly for me, no humans. No human, not even any evidence of humans in these pictures. So I started kind of wondering whether there was something in that. And actually, when you look back at the pictures again, you realize that actually, let me just show you again, what they really illustrate is the effect of a different climatic path that 2 planets take. One was wet and is no longer wet. The other one, thankfully, at the moment at least, is still wet. And I think with every Martian image that you sort of see there, it's a reminder of the dramatic effect that radical climate change can have on a planet. So what of Perseverance? Perseverance was yet to land when I started this project. And there it is. It maps onto an area in central India, just where that red dot is down there below. And I thought, well, thank goodness for that. Here's a country of 1.38 billion people. I should be able to get a picture in a few hours from here, or at least a couple of days, as soon as it lands. So about a year ago, sky crane descent, first images of the surface of Mars, and I quickly started mapping it. It landed at 77.45 degrees north, 18.44 degrees west. No, the other way around, 77 west, 18 north. And there it is. It maps right onto this kind of border between 3 states in central India. I started getting on the radio and doing podcasts to try and find someone to go there and take a photograph for me. Digital Planet on the BBC and Astronomers Without Borders both featured the story. And one of Digital Planet's correspondents, Gauri Abraham, who lived in Hyderabad, contacted me on Facebook, and she said, I think I'm quite close. Maybe I could go there. So she looked into her journey on Google, and it was pretty long. I mean, it's something like 4.5 hours each way if you have a break on the way. She was talking about a 5-hour trip there, 10-hour round trip. The pandemic was raging at the time, and you'll probably recall it really hit India badly that spring. And the thought of sending her on a journey during these conditions was just a no-no. So I gave up. In January this year, Gary got in touch again. She said, well, I think I can do it, but I don't like going on long journeys on my own, so I'm going to take my son, Karthik, and my husband with me. So they hired a driver on the 22nd of January this year, and off they went on this 10-hour epic. It's mad, this, isn't it? Through all these different states. And they draw up at this field, and here are the people at the twin spot to the Perseverance lander living in India. And they are farmers there. They grow some vegetables and some cotton. And the trouble when Gary got there was, of course, she didn't share any language with them. They speak a local language called Anda, which is a mixture of Marathi and Hindi. And Gary really just spoke Telangana. Sorry, she lived in Telangana. She just spoke Telugu, sorry. But she spoke a little bit of Hindi, and she looked up the word for Mars, which is Mangal Grah, and tried to explain to them the significance of their field, this allotment, and how it was twinned to this planetary rover all these millions of miles away. And they just weren't that bothered. But what was thrilling for them was that these people from a city had bothered to come to the countryside to visit them. No one ever does that. And they were so overwhelmed and delighted that they insisted they sit down and have some food, and they took them to their home and gave them tea. And that was really very special. So Gary got home about 9 p.m. that night, having traveled 467 kilometers. And we think that's the first time anyone's knowingly made a visit to a spot on Earth that's twinned to the latitude and longitude of a robotic presence on another world. which is kind of lovely, really. The thing, though, that I took away from this was that, of course, Mr. Ashok there, he's the tall farmer there in the middle. His reaction to them arriving from the city said something to me, which was that most of us live in cities at the moment, and we're so removed from nature that we don't really notice the climatic changes that are really happening. And that's part of the problem in us changing our lifestyles. It doesn't seem very urgent to us because of our urban dwellings. There's the spot, and it's really, although again there's not much evidence of humans, it's an agricultural crop, and a really stark contrast between the same spot on Mars with a different climatic path. One last thought on this. Before Gary left, Mr. Ashok took her to a temple nearby to the Hindu monkey deity Hanuman. And what was really special about this is that Hanuman, in a sense, is a god of perseverance. He's a god of wisdom, of strength, courage, devotion, and self-discipline. And he's prayed to during hard times. And it's exactly, I think, these qualities that we're going to need to draw on to strive, as we strive towards a sort of zero carbon way of life. Just as a little coda to this, then some of you might be wondering, where does Mars's Tianwen-1 lander map onto? Maybe you weren't. Well, totally coincidentally, it maps onto somewhere in southern China, in fact. Totally randomly, I think, probably. I don't think the Chinese planned that. I don't think they're even aware of it, actually, until I told them. So if any of you have any contacts near Guilin in southern China, and that someone fancies a 10-hour round trip to a random pointless spot on Earth, then get in touch. I'm being told to wind up. I was going to talk about one last project, but I realise we're really overrunning badly here. So it's your call. If you've got the stamina and your seats aren't too uncomfortable, I can just do another few more minutes, or I can shut up. Okay. Well, thank you very much. So in about 2017, I started talking to this remarkable company based here in London called 59 Productions. They are responsible for the puppets in Warhorse. They did the London opening ceremony for the Olympics. They project magnificent shows onto buildings all over the world. They are masters of photogrammetry and building mapping. They even projected onto a moving aircraft for Boeing's centenary a few years back. They are just real photon wizards, I describe them as. And we started talking about something we could do for the 50th anniversary of the Apollo moon landings, a project at the time that was called 250,000 miles. And they, at the time, were talking to people who controlled Times Square, and we thought, could we kind of control all the screens in Times Square one night only, and sort of replay all of the kind of footage and join together an amazing sound and light show. So we spent about a year or so sort of talking to them about that, and that all fell through in the end. And it got to 2019, wasn't looking very hopeful. And then the Smithsonian Air and Space Museum called up 59. They'd done a wonderful show at a museum just next door to the Air and Space Museum a few years before. And the director of the Smithsonian at the time, she said, look, we've worked out incredibly that the Washington Monument is the same height as a Saturn V. Do you think you could project a Saturn V rocket onto the Washington Monument for the anniversary, just for a day? And 59 said, oh, I think we can do better than that. And they phoned me up and they said, look, we've been thrown a bone here. Do you think we can kind of create this show that we could project onto the monument instead of Times Square? And I said, yes, you bet. And then the government shut down in America. This is early 2019. There were big rows about the budgets, the national budgets, and there was a budget impasse, and they shut all the national institutions down. There were no checks written or anything. And we kept saying to them, look, have we got a commission here? Should we write it? Time's ticking on. And they said, well, we can't pay you. Our hands are tied. So 59 paid me for a week, and I sat down and I wrote the show just in case it would happen. And then in trying to do that, I started thinking, well, how do I want to kind of capture this? And you'll all be familiar with President Kennedy's famous Rice University speech, the We Choose to Go to the Moon speech, where he talks about the fact that we live in a decade of hope and fear, in an age of both knowledge and ignorance. The greater our knowledge increases, the greater our ignorance unfolds. That spoke to me of the now, of the present. That was the same as 2019 with Trump in office and all this misinformation that we're still struggling to cope with. He goes on, Kennedy, to condense all of human history into 50 years, which was a wonderful opportunity for the 59 team to create this human history all up and down the Washington Monument. So we started, thankfully the budget was cleared at the next opportunity, we were paid to carry on. We started creating, out of all this archive I'd spent years working with, a big show that would play on massive screens up and down the Mall, wrapped around the monument. You can see on the edits there. So when I was making this, that was the stand-in for the Washington Monument, and then these were the sort of 5 or so screens on each side that we were cutting with multiple video layers to create this thing and coordinate it and sync it all up. But, and this was the big but, no one's allowed to project anything on the Washington Monument. It's against the law. In fact, it's against the law to even turn the lights off, the illumination on the Washington Monument. It's like a flame that flickers that keeps America alive. You know, you're not allowed to touch it, which is fine. So we had to get the law changed through a joint resolution that went through Congress and the Senate in record time to make sure we could switch the lights off, but relight it so it didn't look like we'd switched the lights off, and then do all our photogrammetry to project onto it. Yeah, no mean feat. We got the help of the Smithsonian on board for that. But we needed one other thing, one other crucial thing, which was the president's signature. And he wasn't bothered about this, Donald. And so we were hoping it would come through. So we went out there, we camped out, we wired the whole of the Mall for sound and light. And finally, with 3 days to spare, there is his grumpy, angry, raging signature at the bottom. What does that say about him? I mean, my God. He certainly shouldn't have had the nuclear codes, that's for sure. Anyway, there it is. We had no time for any publicity, so in the days running up to it, we were doing all our tests every night. We could only test at night, obviously, when it went dark. We started placing the Saturn V on the monument, and people started noticing, as you would. And so I took it upon myself to walk up and down the monument, telling people to come back on the first night because we were going to launch this rocket off the monument. No one would believe me. They said, no, don't be silly, that's not going to happen. But I absolutely assured them it would, and single-handedly tried to get thousands of people to come along. On the night itself then, and then 3 nights, it ran for 3 nights, we had 500,000 people come along to the Mall to watch it. And I wanted to leave you by playing a clip from the opening. It'll run right through to the launch, because I think that's really special. If you want to leave and get refreshments, that's fine. I'll just play it and we can end there. So here we go.
Spacecraft test conductor for the lunar module reported that Eagle was go. The swing arm now coming back to its fully retracted position as our countdown continues. T-minus 4 minutes, 50 seconds and counting.
We meet in an hour of change and challenge, in a decade of hope and fear, in an age of both knowledge and ignorance. The greater our knowledge increases, the greater our ignorance unfolds. No man can fully grasp how far and how fast we have come. But condense, if you will, the 50,000 years of man's recorded history in a time span of about a half a century. We know very little about the first 40 years, except at the end of them, advanced man had learned to use the skins of animals. Then about 10 years ago, under this standard, man emerged from his caves. Only 5 years ago, man learned to write. Christianity began less than 2 years ago. The printing press came this year. And then less than 2 months ago, during this whole 50-year span of human history, the steam engine provided a new source of power. Newton explored the meaning of gravity. Last month, electric lights and telephones and automobiles, airplanes became available. Only last week, we developed penicillin and television. and nuclear power. And now, if America's new spacecraft succeeds, we will have literally reached the stars before midnight tonight. But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other thing. Not because they are easy, but because they are hard. If I would say, my fellow citizens, we shall send to the moon 240,000 miles away from the control station in Houston, a giant rocket more than 300 feet tall, made of new metal alloys, some of which have not yet been invented, fitted together with a precision better than the finest watch, carrying all the equipment needed for propulsion, guidance, control, communication, on an untried mission to an unknown celestial body, and then return it safely to Earth, re-entering the atmosphere at speeds of over 25,000 miles per hour, causing heat about half that of the temperature of the sun, almost as hot as it is here today, and do all this, and do all this, and do it right, and do it first, before this decade is out.
T-minus 1 minute, 35 seconds on the Apollo mission, the flight to land the first men on the moon.
And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked.
We passed T-minus 50. 55 seconds and counting. Neil Armstrong has just reported back. It's been a real smooth countdown. We're on internal power with the launch vehicle at this time. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 33 minutes past the hour. Liftoff on Apollo 11. Tower clear. Neil Armstrong reporting the roll pitch program which puts Apollo 11 on proper heading. Plus 30 seconds. Altitude's 2 miles. Apollo 11 Houston.
Oh, sorry. Thank you very much. Thank you. I know I've massively overrun, so thank you for your patience. I'm here at the front to answer questions if you want to come up, or I don't know how you want to do it, given the time. That's fine. Come down and talk to me if you'd like to. Yeah. Okay. Hey, it's a pleasure. Oh.
manufacturing new super materials in space. So with no further ado, I'd like to pass it over to Andrew.
Thank you, Alden. Good afternoon/evening, everyone. So thank you for coming to this. My name is Andrew Bacon. I am the CTO and co-founder of SpaceForge. What is SpaceForge? So mission statement up here, but we are an in-space manufacturing company, but specifically we're making things in space that you can only make in space and then bring them back down to Earth to help humanity. And we have the ambition to both make the world's first relaunchable and reusable satellite, but also to become a carbon negative company while doing that. Why? So, turns out, Earth is a pretty terrible place to make things, for many reasons. First of all, gravity. Okay, we like gravity, it keeps us on the ground, but gravity causes big issues when you are trying to make an alloy of two metals. If I was to melt lead and aluminium into a sort of try and make a nugget out of them, what's going to happen? The lead is more dense, so it's going to sink to the bottom. The aluminium is going to rise to the top, and you're going to have a differentiated alloy. So that's a big problem with alloying we have on Earth. Atmosphere as well. We love the atmosphere, it gives us lovely oxygen to breathe. The problem with oxygen is when you heat up a metal, it gets very hot, and when you get certainly above about 500 degrees centigrade, the oxygen in the atmosphere starts to disassociate, and it oxidizes that metal and causes it very brittle. And even when you're doing any kind of operation, oxygen is really hard, and the atmosphere is a really hard thing to keep out of all your operations. Temperature as well. So it's pretty, on Earth, it's pretty difficult to make any kind of temperature less than -50 and more than +50. That's kind of the natural range we experience on Earth. But if you're trying to get down to the extremes, like if you want to go down to close to absolute zero, you have to use cryogenics, which is very expensive, very difficult. And if you want to get to the really highest temperatures, like tens of thousands of degrees centigrade, you have a real problem because the atmosphere doesn't want you to do that. So basically, making things on Earth, not great. So why make things in space? How does that help? Firstly, weightlessness, microgravity. So that problem I mentioned before about when you melt metals and you try and mix them together of different densities, in space you don't have that problem. There is no up, or there is no down. Those metals will mix together perfectly. And this really helps certainly when you're making crystal formation, but any kind of alloys and things like that. Vacuum. So in space, well known for being in the vacuum, the average pressure of space, about 500 kilometers up in the atmosphere, is roughly 10 trillion times less than that of the surface pressure on the Earth. And that's the kind of vacuum that would take you multiple stage vacuum pumps to achieve. In space, just open the door, free. Near zero, so as I mentioned before, if you want to go down to sort of cryogenic temperatures, like down to into the tens of Kelvin, on Earth you need to have a cryogenic fluid. In space, just don't point at the sun. The cold space is about 10 Kelvin, so if you point a radiator at space, your radiator will naturally go down to about 10 Kelvin. So when you mix all three of these together, the microgravity, the vacuum, and the cryogenics, you can suddenly make new things that are just not possible to make on Earth. Am I talking complete rubbish? Well, there has actually been a lot of in-orbit manufacturing going on for the last 50 years. This is not a very well-known thing, but if you can go way back, Skylab, but even before that, even on Mir, there were experiments on growing semiconductor materials like gallium arsenide. The Wake Shield facility, which was a NASA-launched, basically a giant dinner plate, which was there to basically deflect the residual atmosphere you got because it was quite a low orbit. They were also growing gallium arsenide films and other kinds of semiconductor films in orbit, and their overall conclusion was, yeah, it works. Unfortunately, with the Columbia disaster, that kind of program kind of came to an end, but it hasn't really been resumed since. But since the year 2000, we've had the International Space Station. That has been a fantastic place to carry out all sorts of things, 3D printing of ceramics, testing out of pharmaceuticals, and to a lesser extent, testing out of making new alloys and semiconductors and things like that. The problem with the space station is it has astronauts on it, and we like astronauts. And as soon as you start messing around with, let's say, melting lead and aluminium together and potentially releasing lead vapor into the side of the space station, people tend to get a bit worried. So what is the solution? The Forge Star. So this is the satellite, reusable satellite I've been mentioning. This is SpaceForge's main product. So we are building an independent manufacturing satellite that goes into orbit, makes these new super materials, has no people anywhere near it, completely uncrewed, because people are dirty and messy and they need air to breathe. It's very inconvenient. So Forge Star is entirely autonomous. It can go there, make materials, and then when we're done making the materials, we bring it back, and we bring back 100% of the satellite we launch. And that's one of our major innovations, is our re-entry technology that allows you to bring the whole thing back. That's quite different to pretty much every re-entry system today, where you usually have to leave behind quite a lot of the mass. But if you're ever going to get to the point where we're actually having production that is feeding into production lines on Earth to make these new materials, you need something like this. Just a little thing about our approach as a company. So we like to build things, we like to break things. If you go and visit our stand in the exhibition hall, you'll see one of the things, early prototypes we built and broke and everything. We like to I like to say, in the space industry, I mean, I haven't really said my background, but I worked in the space industry 10 years, and we do a lot of simulations before we put anything into orbit. But at Spaceports, we're very much about let's test and simulate at the same time. Simulations give you an idea, tests give you the truth. Simulations and testing at the same time gives you understanding. So we also like to document as we learn. So I've got some things here. So we've been doing some heat shield testing in the vacuum. We've been flying drones, dropping small versions of our satellite at airfields. We did a balloon flight. That's one of the ones in the bottom corner to test out our tracking. And on the right, we're doing some re-entry modeling software to be able to predict where our satellites are going to land because we want to land them quite close to the coast of the UK. Who are we? So we've gone from 2 people and a garage to 28 people in the last 2 years. We've now got this was us on the opening day of our facility in Cardiff, opening up our manufacturing centre with some of the team there. Yeah, we're 28 people now. I've got 4 more people starting in the next 2 weeks. We expect to be 45 by the end of the year, and maybe double that the year after. We've set up a new clean room there in Cardiff as well, so it is Wales's first satellite manufacturing facility. We are 100% focused on the space-to-Earth manufacturing market, and we've got a first launch this year and another launch early next year, and maybe some more the year after. So we've worked with all sorts of people like the European Space Agency and elsewhere. And more importantly, we've been working with customers on the ground who've been saying, you know, we go to them and say, right, do you want this new super material? And they're like, okay, brilliant, give us some samples. And that's one of the key things, you've got to be talking to customers. So I'm just going to kind of wrap up here, just saying, you know, keep in touch, keep an eye, and we have 2 job openings open at the moment, a payload systems engineer as well as a structural engineer to help us design our satellites. We will also be having some spin-turnships open very soon. They'll be advertised on our website, but we will also be posting all of our early careers jobs on Space Careers UK, which is a fantastic website, and you should all go onto it repeatedly. So that's kind of all I wanted to say. I mean, in terms of, I haven't really necessarily touched on the whole carbon negative thing, but for us as a company, we're really focused on making new materials. What my co-founder Josh Weston and I, we realized early on is, because you leverage the benefits of microgravity and ultravacuum in space, this enables you to make alloys that nobody's ever thought of before. Effectively, you could mix lead, aluminium, but you know, rubidium, oxygen, whatever you want to mix together to make a new alloy just isn't possible. And what that means is effectively you can use space to make billions, maybe even trillions of new products that just haven't been thought of today. Now, not all of them are going to be worth the price of launching them into space and bring them back, but only a tiny fraction have to be worth it for us to be able to build a business out of this. And we realize there are so many things we could be making. Let's focus on the things that really help life on Earth by making things like being able to make new materials for aircraft turbines so that we can make them bigger and make them more efficient, or being able to assemble stronger bolts so we can make a bigger wind turbine, or more efficient semiconductors so that we can reduce the energy consumption of, say, the telephone network or the cell tower network, or being able to make the switching of the power network more efficient. There's these small changes that you can make in terms of making new materials that have a big effect on Earth. And that's how we plan to be carbon negative. So I think that's it for me. And if you want to come and talk to my team are going to be around the rest of today and tomorrow up on our stand. Please come and talk to them about and ask them any questions you'd like to see. And it's been great talking to you. Thank you, everyone. If we've got time, I'll let her choose. Yeah, in the middle, yeah.
What about the classical paper stuck in the printer problem?
Paper stuck in the printer problem?
Like, we know humans in orbit to actually fix these refinery satellites, basically. What would you do in that event? Because you can't possibly predict every single failure scenario.
Yeah. So, I've spent my whole life working on space technology. And one of the things is, when we think about what's expensive in a space mission, so a lot of people think that the launch is the most expensive part of any space mission. That is not true. Certainly today, I mean, if I bought a HAL Falcon Heavy, that's about $1,000 per kilogram. Some other rockets, more like $50,000 per kilogram. I've previously done parametric studies on the cost of spaceflight hardware. And the answer is that the design, build, and test of a kilogram of spaceflight hardware ranges from anywhere from about $50,000 per kilogram for even the smallest 1U CubeSat to around about $2 million per kilogram if you want to land on Mars. That's the range. So actually, the cost of launch is not the dominant factor. But why is that? It's because when we launch stuff into space, we generally design it to be up there for 5–10 years, and you can never touch it again. Hence your problem about getting the jam, printer-loaded paper getting jammed. So we would spend a lot of time designing a way of preventing that jamming. We'd have redundant mechanisms, things like that. And that kind of require the testing and everything like that is what causes satellites to be so expensive. If I was to design a car like I do a satellite, i.e. I would never be able to touch it for 10 years after it came out the factory floor, it would have 2 engines, it would have 6 wheels, the structure would probably weigh 3 times as much, it would only drive at 3 miles an hour, and it would cost me 10 times as much. Because that's the problem. But when we don't do that, we bring cars into the shop, we get them serviced, and we get them repaired. So, to answer your question, doing these new kind of manufacturing processes is difficult. There will be things that get stuck and broken and everything like that. We bring the satellite back, we repair it, we make it better, we launch it again. That's the difference.
In a sense, the reusable characteristic does save your system. That's something I did.
Yeah.
Thank you.
Got time for one more?
Oh, no, it's okay.
Hi, Andrew. Thanks for the great presentation. I'm just wondering what's better about the re-entry prediction software than other technology out there?
Yeah, thank you. So it's very interesting. Like Spaceports, we never set out to build anything that we could buy off the shelf. There's one thing you cannot buy off the shelf, and that is accurate satellite re-entry prediction software, unfortunately. So we had to set out and design it ourselves. And we realized one of the main problems with satellite re-entry predictions, I'm sure many of you have seen sort of in the last couple of years that there's always this sense of panic, certainly in the media, whenever there's a large object that's going to re-enter. Everyone's like, oh no, the original Chinese space station, people are like, where is it going to land? Nobody has a clue. Now, the main reason why nobody has a clue is because the atmosphere above about 50 kilometers altitude is very difficult to sense. Below 50 kilometers, we can do it with radar, we can do it with balloons, and that captures most of the weather we can do today. But above it, we have very little knowledge, and it's extremely variable. It's driven by the sun and various other factors. So the knowledge of how thick the atmosphere is in what we call the lower thermosphere, about 50 to 500 kilometers altitude, is really rough. So the only way we're going to be able to improve those weather predictions, which then allow us to better understand where a satellite's going to land, is to routinely fly through it. And that's part of our business model to do that anyway. So we're going to be routinely flying through it because we want to be delivering stuff back. So our software is about using the data from real satellites coming back in to feed it in to get better weather predictions to make the next satellite when it comes in more accurate. Does that answer your question?
That's unfortunately all the questions we have time for. But thank you very much, Andrew. You can see Space Forge upstairs in the restaurant.
Yeah. Thank you, everyone. Have a good conference.
enjoy it. We have a great lineup of panelists for you today. And then directly after this will be the awards ceremony. So if you have any questions, you can put them on at the link at any time during the panel. So please let us know. But also, if you're here because of kind of the time afterwards, we ask you, you can go and ask the panelists questions as well after the panel. So that's okay. But yes, so welcome to the Space Data panel. I'm going to introduce our panelists initially, and then I'll hand over to them. So first off, we have Ken Gordon, who's our panel chair, who's from ESA Space Solutions. Then we have Andrew Fournet, who's from Astrosat. Then we have Zaina Rahman, who is a YGT working on 5G and 6G. And then we have Jacob Geer from UK Space Agency, who works on space debris and Earth observation sorts of things. And then we have Guillaume, I'm very sorry, Tanier, who is from Lean Space and is the CEO and founder and works more with kind of upstream space data sorts of things. But I'll let them kind of introduce themselves and hand over to Ken now for the remainder of the panel. Thank you, everyone.
Thank you, David. Is this on? 1, 2. I just love saying that, sorry. My name's Ken Gordon. I am one of the European Space Agency Space Solutions Business Ambassadors covering Scotland, Northern Ireland and beyond. It's a delight to be here, and it's been great to be here all day because to feel everyone's energy and difficult questions, slightly scared by the difficult questions I've heard this morning, and also to be with so many different colleagues with fantastic backgrounds and expertise across data. So I'm assuming you're here because you're interested in space data and careers in such. And we've got a fantastic range of organizations. You will learn things today because I've learned things talking to people about the different types of data, the different ways we treat data. I will do, we've had us all introduced. So we'll introduce ourselves. If we could say what we do and why we came into this industry. I'll start. We okay with that? Yeah? I'll start. My name's Ken Gordon. Why did I end up doing this? Well, I joined ESA 2 years ago. So here's good news. You don't have to be young to get into the agency or into industry. You can be in space any time. And my background isn't actually in space. Why am I doing this? Space is cool. As a kid, I collected breakfast cereal tops to get the Apollo patches. My family lived on breakfast cereal for quite a while. Like a lot of students. Maybe that's not true nowadays. And I also had my little action man. Does anyone, hands up anyone who knows what an action man is? Wow, I didn't expect that. I had a spacesuit, I had a Mercury capsule, and when you took Action Man's space boot off, his foot came off. That made me distressed. So, that's why I do that. Over to you, Andrew.
1, 2, yes, can you hear me? Okay, 1, 2, 1, 2. Bonjour, je suis Andrew Fournet. Okay, all right, so I'll do it in English, fine. So my name is Andrew Fournet. I'm Innovation Lead at Astrosat. Astrosat is an Earth observation company, and we do a lot of crazy stuff, which we'll talk about later. How did I get in the space industry? I got headhunted, actually. I'm from oil and gas to start with. I think that's quite important because space needs people from outside of space, and to bring different kind of expertise into space, so commercial abilities and so on, and then thinking outside of the box and so on. So yeah, that's basically me.
Zaina.
Hello. Oh, there we go. It's working. Hi, everyone. I'm Zaina. I'm a young graduate trainee for the European Space Agency as well. And I work in space for 5G and 6G. And how I came into the space industry, well, I sort of fell into it because I studied maths and physics, and at the time I didn't realize the career options in the space industry. I thought, you had to be an astronaut and then there's nothing else. So after networking and going to different conferences, I realized that maybe I can get involved with the industry. And I'm currently part of telecoms, and I'm really enjoying it, which is good. And I think it's a good opportunity for young people to get involved, and this is a really good way to get there. So yeah, that's how I came into it.
Jacob.
Hi everyone, good afternoon. So I'm Jacob Geer from the Space Agency.
I lead a team of much cleverer people than me in the Space Agency that monitor orbital collisions for potential dangers to UK spacecraft. I got into the Space Agency or the space sector. It took me quite a long time. I'm a psychology graduate. I worked for a market research company doing data analysis, so using SPSS and Excel a lot about yogurts, bizarrely. Then I moved into Ministry of Defence, and I looked at some different subjects, but again using my data skills. And as time went on, I started looking after people and leading programs and teams. And then eventually I found my way to the Space Agency. I didn't know we had a space agency when I joined. I found there was a job, and I thought, fantastic, this is my chance. And I made that move across because space is just something that's always inspired me, and is something that when I go to talk to people in the evenings in a social setting, people want to talk to me about that. It's really nice. And some jobs about yogurts, they don't. And so that's why it's a real pleasure to be here now. Thank you.
Guillaume.
Hi, so my name is Guillaume. I love the question, why did I join the space industry? I'm going to start with that. It's very good. I think we should all ask ourselves. Personally, I'm seeing the future like 500 years from now or 200 years from now, and we look at the time of today, like the early 2000, you know, the first 20 years or 30 years, and we keep this moment as the moment when humanity really went to space. You know, like really like made this real, and I wanted to be part of that. So I was a software engineer, and I'm still a software engineer, even if I'm doing more business stuff now. But at some point, I wanted to apply this software domain into space. So that's why I joined this business. And I will also answer the question why I'm in this panel. I'm a software engineer, so I love data, of course. And data is more and more data everywhere, as I'm sure we'll discuss about that. And I love space. And you know, I thought, what can I do to be doing space data? So software is a perfect place for that. I worked in the industry around space data for many years, and I'm particularly interested into the tools, the systems, the software that is generating the data or using the data to make sense of it, right? Because data on its own doesn't help so much. You need tools to make sense of it. So I'm going to explain you, I'm sure about that a bit later.
Okay, here's the general question for the whole panel. What skills are needed in this part of the industry right now? Or do you foresee will be needed? Down the line? Yeah, let's do it, Andrew.
Right, so obviously software, data scientists, developers, especially developers these days. My company needs developers, so anybody who wants to join us, just apply. But there's another thing that we're looking for is, again, as I said earlier, people that are not scientists. So we're going to be doing some events about recruiting artists in order to see the visualization a bit differently. So looking at the data and how should it look. So I'm looking at people in design and so on to make that space data available to people in a way that they understand it. So that's really important, UX designers and so on. So yeah, that's the kind of skills that we need at AstroSat these days.
Oh, artists. Interesting. Zaina.
There we go. What skills? So what skills are needed? That's a good question. I think for getting into the industry, I would say networking is key. Being able to work with others, because that's really what you're going to be doing in your role, and being able to communicate and project manage your projects at whichever role you do, not just in this industry but in others. And I'm also part of this organization called New Voices in Space. And here we are introducing a program to help students into the industry. So we have this fellowship program where we provide students with mentors both in the technical side and in the business side. And this is just to help them, learn from these mentors who have a lot of experience in the industry. And there will also be some paid internships in between in the summers, which, from my experience, is really difficult to get without experience. Some roles require experience to get experience, and it's just this awful cycle. So we want to break that cycle. So if you're interested, please feel free to get in touch. I'll be posting on LinkedIn as well. So to answer your questions, that is quite a long-winded answer, but yeah.
That's great, thank you. Jacob, what skills?
I think the skills that we see the need for most right now, there's, in my area, there's the need to build software, so I need coders and software engineers. I need physicists who understand orbital dynamics in particular, so how spacecraft behave in orbit and how you can propagate or estimate an orbit going forward once you know their position. I probably need some artificial intelligence or machine learning experts and data scientists to use the reams of data that we already have. So space sustainability, where I work, is not a data-poor environment. There's a lot of stuff out there. It's just finding the insight from that too. And then finally, I need systems engineers, I need project managers, and I need diplomats, who are a bit random compared to everyone else, right? Because this is an international issue. So I can't fix space debris, which is what I want to do, just me, the UK alone. I need people to go out there and talk to other nations around the world about why it's everyone's problems and how we should all work together on what the solution is. Thank you.
Thank you. Diplomats. Who wants to be a diplomat? Who can be diplomatic? Guillaume.
Yes, so two of you have mentioned software, of course, so I cannot use that. Although I think I see that for my company, I mean, we are recruiting a lot, like everybody, and we see that all the space companies, most of them actually, are very good at mechanical engineering, and they are very good at knowing how to build hardware and satellites and test them, but a bit less at actually building software. So I really emphasize it's true, it's a very key point, and not just like MATLAB and Python, like, you know, building professional level software. And that's also a thing we solve with Lean Space, and we help companies do that. But okay, I will go to the next one, which I think is more interesting, because there is so much energy now in the space industry. I'm sure you see startups everywhere, a lot of funding everywhere. So I would say the biggest talent now is entrepreneurship. If you are able to come up with an idea and know how to formulate a business model and make a business out of it, that's a very, very good skill. And really, that's the time. Now, I mean, I can tell for France, I'm sure it's the same in many countries, there is literally billions of euros going to be spent to finance startups. And so if you have an idea, go for it, guys.
To echo something that someone said this morning in the Spaceport panel, this is a great time to be entering. I wish I was coming to this at your stage in life. Okay, so, and today I have spoken to physicists, people studying philosophy, people studying data science, the humanities. It's some super, super spread. So I hope you feel, listening to all of this, that it's accessible to everybody, really, if you really want to get into it and find your space. Now here's, to demonstrate how diverse this panel is, I'm going to ask specific questions to individuals. Hurrah. Andrew. The Spaceport panel this morning was really, really interesting, apart from the fact that there was lots of Scottish ones there, and the questions were fantastic. Super questions, folks. They touched on sustainability. How can the space data community or space data help in making sure space in the UK is sustainable?
Thank you for your question.
You're welcome.
So I think space data has got definitely a role to play, Earth observation particularly, in sustainability, because right now sustainability is about, you know, net zero, but it's working a lot on theoreticals. There's no hard measure, and that's what EO does. It measures stuff. So being able to measure the sustainability element that you set yourself and then that government are going to set to you, and being able to report that is what, well, Earth observation is about, reporting and monitoring what is there. So this morning when the sustainability, the panel talked about sustainability, I mean, they're building big infrastructure projects in Shetland and so on, what's the impact? And they're telling us, great, it's sustainable, it's no impact to the environment. Prove it. They're going to be asked to prove it, and that's where space data can help. You're going to have ground data to help also, obviously, but space data is going to be able to monitor through time, because that's what space data can do, time travel. You can go back in time and verify what was there before, what is there during, and what is going to be there probably after. So yeah, definitely Earth observation space data has got an element to play in that sustainability claims that people are going to give. And it's not just the Spaceports, it's everybody. So any organization, this infrastructure organization, big industry, they're going to be building, I don't know, a factory somewhere to impact an environment. How do you mitigate that? And how do you have nature-based solutions in order to what are the nature-based solutions you're putting in place in order to mitigate all these bad things you're doing. That's, I think, what space data is going to be able to do, monitor and report.
That's very good. Obviously, Astrosat, I think your job title is, what was it, something to do with coming up with brilliant ideas or something?
Brilliant. Thank you. No, it's mad ideas, really.
Mad ideas, crazy ideas.
Any idea that you guys come up with, just give me a shout, and then we'll make, well, my boss says every Earth problem has a space solution. And yeah, we've done a lot of stuff about, from bread and butter Earth observations, which is deforestation, for example, weather forecasting and all that. But we've taken it to a different level with social data. So we were able to help during the pandemic with mental health issues using space data. So I don't know how many of you thought about that before, but it's something that we did. I didn't know we could do it. I was told, actually, Andrew, that data set, that transport poverty index that you built using space data helps me with transport anxiety issues. That green space access index that you built helps us enable people to go outdoors for their mental health. Fuel poverty is also something, sorry, I'm rambling. Fuel poverty is something that we did also. That has an impact on mental health. So all these data sets are from space. They're combined with ground data also, but I bet nobody in this room thought about mental health and space data together until now. But it takes basically doing it in order to show it. So yeah.
Thank you, man.
Sorry.
It's fine. Zaina, you talk about 5G, 6G. I'll be honest, a lot of that stuff is kind of a bit over my head. What on earth can communications do for our world without feedback?
I don't know if this is working. Yeah, so in my role at ESA, I'm working on integrating satellites into 5G terrestrial networks. And this is something that's quite novel. And the reason for this is that satellites can provide three things that we're focused on right now is seamless, ubiquitous, and resilient connectivity around the whole world. And because satellites are so high up in space, they can cover a large area of Earth, meaning that, sorry, technical issue. Yeah, there we go. Meaning that it can cover remote areas and
make a difference.
Yeah, no worries. So it can cover remote areas. So I've heard of some people walking around 3 miles to get a phone signal in areas that they live in. And you can just imagine what this can do for the entire world, especially from underdeveloped countries that aren't connected. And even during the pandemic, we relied so much on the connectivity for remote education, for working from home. So there's a lot of areas where this could expand on. So back to Ken after he fixes his mic. There you go.
No, good. Hello. Thank you, Zaina. Sorry, I was a bit distracted there. One of the interesting things we were talking about earlier on, and again, here's a question that I think is cool. Jacob, what data do we need about space that comes from space? There you go.
It's a good question for me, because you told me the question earlier, right, so it's good.
Don't give it away, Jacob.
It's a good question for me, because I'm interested in about avoiding space debris, about tracking space debris, understanding what's up there. And actually, at the moment, a lot of our observations about space debris come from ground-based radars and telescopes, particularly ground-based radars run by the US military. That's where 90% of the world, excluding some difficult countries, get their space data from about space debris. And so actually we need to start changing that, A, because we can't always rely on the US, but B, because of the amount of new debris and rockets and satellites reaching space. We can't actually keep up with that anymore. We can't track the smaller pieces of debris. And so we need more space-based sensors as well as more ground-based telescopes, lasers and radars. And particularly we need to have observations from spacecraft, maybe utilising their current equipment, so reusing it or looking at the data in a different way. A lot of spacecraft operators will use data techniques to cut out data about space debris to look at the stars instead, to use their star trackers, for example. actually. That's quite useful data for me, but they've cut it out because they don't need it to do their job. So there's a whole new world of data out there I can get if I just get access to it the right way. And then I think we need in future more actual sensors dedicated to space debris. So inspection of space debris, working out how large it is, working out a broken satellite or an old rocket body. Is it tumbling? At what degree is it tumbling? How quickly? What is its orbit? These are very difficult questions to answer with ground-based sensors only. And that's why we need more data from observations in space and new satellites to actually help us remove debris in the future.
Thank you very much. Guillaume, we've talked about a lot of people. One of the things I do is I help companies. I've got money, number one. I help companies understand and apply for funding to use space data or space assets in their business to solve problems. A lot of people think space data is weather and pictures from space, but it's much more than that, isn't it?
Yeah, I mean, definitely Jacob gave some example first, which I think is very relevant. It's true that when people think about space data, we all think about the applications, for agriculture or logistics or whatever, which is the outcome, the output of the space industry, right? But to produce these products, there's a lot of things you have to do, a lot of operations you have to run, a lot of satellites you have to build, a lot of missions you have to design, a lot of data you have to generate and exchange. And so what Jacob is talking about, like knowing when are the debris coming, if they are tumbling or whatnot, all this type of data is used in operations. For example, if you want to remove a debris, right? And all this operational data or engineering data, I believe it's one of the biggest topic for innovation in the coming years, coming decades. And so I can give you some examples, which is what we are building on. When you run operations, for example, when you have your satellites in orbit and you need to manage it, you need to manage the telemetry of the satellite, all the data coming from it to know if the satellite is healthy, the level of battery or whatever. You need to know where it is. You need to be able to simulate its position. You need to be able to propagate orbits. You need to find a way to get the data from the satellite to the ground. You need to be able to know if there is weather events or debris or any type of things around. And all this is just for operations. Now, if you want to plan activities, you need to generate plans, knowing what the satellite will do when. All these operational plans are data behind. We tend to see data as, I don't know, bits or 1 and zeros and whatnot, but in reality, it's actually objects that you work with. Right? If you go more early in the mission, before operating, you need to build the satellite. You need to test it. So you are running lots of tests. Is my hardware fits to requirements? We saw, for example, just earlier today, a very interesting session on system engineering from someone from Inmarsat. I mean, maybe some of you saw it with the V-cycle and MATLAB scripts and 3D views and whatnot, all behind its data, right? It's data that sits in a hard drive, if you want, or memory. But being able to make sense of it, being able to have new tools, more innovative tools to generate and to make sense of this data is how you can test, operate, build better. There is a lot of companies now which are appearing, lots of so-called new space startups who want to do better. They want to innovate and do better than what we have done in the last 30 years. That's wonderful. But for that, you can get better materials or better components, or you can do better process. And so data here has a key role to play because the way you design, the way you build, the way you test, the way you operate your systems will make your business much more agile or much more predictable. So in that sense, this is the part of the space data that helps produce the output of the space industry, right? And I believe really the way you build the tools to make sense of it is fundamental. So I'm going to give you a quick explanation also of the tools, because what we see is a lot of people, a lot of companies are trying, as I said, to do better. And they are trying to rebuild, again, tools to design, to test, to operate. And you saw, for example, just before the presentation from Spaceforge, it's a super unique use case, super complex use case. I mean, nobody really has done it before. being able to bring satellite back and send them back again in space and manufacture things, it's completely new, right? So you would need software tools to capture a process, to develop and test and operate these systems that doesn't exist today. So you have so many companies who are coming up with new ideas, completely new business models, and all of them will have to rebuild everything, reinvent a bit everything. So what we wanted to do at InSpace is to provide these basic functions for you to manage space data, to manage to collect space data, to manage to make sense of it, all the basic 80% that everyone needs, you know, and empower our customers, which are these space organizations, to build their custom software tools, which are specific to their use case very quickly. So that's what we call an open innovation platform, and that's basically what we do at InSpace, to help these customers manage the data and make sense of it.
Right, thank you very much, Guillaume. We know that we're quite limited for time here, so think of your questions, get your questions prepared, and finally, the final question to the panel before we open up to questions is a question I like. So thinking about when what you expected when you joined the space industry and where you are now, what would you tell yourself just as you were joining the space industry? What wise words would you have? Andrew.
I think I'd say to me 3 years ago, I'd say get ready to rock, because there's so much stuff, your mind's going to be blown, and there's so much things that you can do. I mean, I only touched on the tiny bits that we're doing, but we'll be doing stuff about homelessness with space data, dementia with space data. I mean, this is just, it blows my mind every time I think about it. So yeah, strap in, basically.
Strap yourself in, yeah, cool. Zaina.
What I'd say to myself, not too long ago actually,
Okay,
when I joined the space industry, I would say be open-minded. There's things that you might not realize that you'd get into at the start of your career, and I've been pulled in from different areas. You know, I've been working with robotics. I didn't have a clue about that till now. So yeah, be open-minded is my key one.
Thank you very much, Zaina. Jacob, what would you say to yourself?
I was amazed when I joined how many companies and industry was the space sector. I thought it was just like NASA, right, and ESA, and that was it. But I was amazed by how many companies there were out there. And so I'd say to myself, don't be afraid to have ideas, to try things in a business sense, to give it a go. You've already said to give it a go, right? I didn't quite have that in mind when I joined the space sector, although I'm still the agency now. It's great to think about that in the future. Let's just give it a go.
Okay, Guillaume.
Learn how to press the mic. I don't know, man. It's very tough because I'm pretty happy about the time I arrived in the space industry, and I'm pretty happy with the path I've managed. Maybe an advice, it's maybe seizing opportunities. I think I was lucky enough, and I was maybe good enough to seize opportunities when they arrived, to get them and seize them. Maybe I missed some, and I think a lot of people miss opportunities. So if you are presented with a great job opportunity, I don't know, go to another country to learn something unique, just do it, because opportunities, they are there and you have to take them. If you don't take them, then you don't evolve. So maybe that's my advice.
That's really good, and that kind of echoes what you were saying, Zaina. Who's got questions? Hands up, please.
We have had some questions online as well, if you want us to read them out.
What do you want to do? Online first?
Let's do an online one and then we can go to the room. So, yeah, sorry.
Ask again.
Sorry. So the question is, what percentage of data is actually useful data and can be manipulated, or can all data be used in some way?
Ooh.
Say again?
What percentage of data? Can you repeat the question?
What percentage of data is actually useful data and can be manipulated, or can all data be used in some way?
Cracking question. You want to go? Yeah, dive in.
I think all of it is interesting. It's what you make of it afterwards. So even if you don't see something straight away, so if you get an optical that's got clouds on it, then you can learn something out of that. And then it's applying, so knowing that, for example, if you're in equatorial areas, you're going to get a lot of clouds. So what are you going to go and use next in terms of technology? You're going to use SAR to go through the clouds. So all the data is going to be useful because you're going to learn something every time about what you're looking at. And then because if it's not obvious straight away, it doesn't mean you can't do anything with it. So you just have to carry on and keep at it. So I'd say all the data is useful.
Guillaume.
Yeah, I would add one thing. I've seen it many times in my career. It's like you generate data, and then you're going to generate it for one purpose, and then you come back 2 years later, the same data set, and now you have a new idea, and you realize something new, and then you make sense of the same data, but you get new insights. So you see that now and now it's like petabytes and petabytes and petabytes of data because you want to keep it, right? And okay, you can argue if it's good or not, I don't know, but it's very useful for sure. And more and more you see companies and businesses able to generate completely new things by correlating data, which were completely not designed to be put together, whether it is for applications or whether it is for Industry 4.0. You generate a lot of data from everywhere, and then you see what you can do with it. So I think, all data is useful, and over time we'll find more and more ways with, artificial intelligence or better correlations or whatever to make more insights and more knowledge about this data.
Okay, David, what else have you got? Go to the room. Okay, who's got a question? And make yourself known, and there's a microphone. I think we're over here. Over there? Over there.
Hi guys, cheers for your insights so far. Thank you for coming along and for everything you shared with us. So I was going to ask, basically every single one of you has said software engineering is going to be such a key part to the industry. It is now and it will be in the future. I come from an aerospace engineering background, but I've got a really keen interest in sort of software engineering. What is the expectation for me coming in from another discipline to join the industry?
Yeah. Okay, so we want to hire all type of profiles. We are looking to hire, yes, software developers for sure, but also software testers, people who are able to test whatever we build for a use case. We are looking for ground segment architects, people who are going to not code or anything, but understand how to develop a ground segment system and its software. Solutions engineers, people to work with customers, to help them use our product to build solutions. So there is a bit of biz dev and relationship and all these things, all these fields are software. Software is not just coders. Coders are a key part, but there is many, many more things. So I would say take your key expertise, maybe in the way you designed your hardware or I don't know, whatever you like, and try to bring this as a niche know-how next to basic software knowledge, and I'm sure you can find something.
Another question from the floor?
Oh, could I
sorry,
jump in
Jacob,
there?
sorry.
So from my point of view, within the agency, we contract out our coding. Most of the time we go to companies like yourselves or others. But we need everyone to be digital aware of how a project is run, so to understand how their discipline, in your case engineering, might match to a digital project through various phases, an alpha, a beta, for example, at a very basic level, and then also understanding some of the key roles and the systems architecture just been described. So no matter what your discipline, I think you have to have those digital skills to succeed and go further, and it's something that a lot of people pick up at university just as they do it, but if not, it's a great thing to learn as well.
Thank you very much. Another question from the floor. Do you want me to help? I've got a mic here. Rolling chair.
Hiya. My question was more for Zaina and Jacob. Obviously, with space debris and us sending more satellites through companies like SpaceX, there's an increased risk of collisions and catalytic events. How much of a risk do you think that is for future space travel and telecommunications at the moment? And is there anything that you think we can do to solve it?
Who's going to answer that one?
Hi, that was a good question. In terms of space debris, of course there's a risk with sending more and more satellites into space. Around 10 years ago there was 1,000 satellites in space. Now we're sending around 1,000 every year. So with that we have programs to help collect these space debris. and dispose of them in a sustainable way. And I know there's other companies out there that are working towards that as well, and I'm sure Jacob could expand on that part.
Yeah, for us, so my team monitor about 1,500 to 2,000 potential collisions every month. That's just involving UK spacecraft. We have a fleet of around about 400 spacecraft in orbit now. The US, for example, monitor tens of thousands to millions every month of potential collisions. And so you can see the data problem there, like trying to cut the actual collisions from the false alarms or the not quite there as well. And it is a growing problem. So the increasing number of spacecraft reaching orbit is something that we have to do something about, but no one nation can do it alone. Because if we choose, for example, to regulate, to stop our satellite operators from doing something risky, for example, and no one else does, it makes the UK uncompetitive. And so actually, to do something about that problem, you need international action, you need the UN guidelines on sustainability to be updated, you need action at the European level, at national level, at G7 level, and to do that all in combination as well.
Perfect. We have a question over here. No?
Hi, thanks. Do any of you use mathematicians in your field or teams? And if so, what kind of roles do they have?
Mathematicians, we use mathematicians. So, top of my head, mathematicians, I don't know if they've... So I've got a data science team behind me, so I'm not the clever guy in the company. I've got loads of clever guys and girls with me that help me do stuff. They're astrophysicists, mathematicians, I don't know actually, but I can see usefulness in mathematicians in our business because there's a lot of formulas that we have to build. When you're, I'm guessing, this is now guesswork, when you build an algorithm, I'm guessing you need some sort of mathematical know-how. So you're going to have that as a core skill in order to be a data scientist, I think. But yeah, yes, indeed.
Yeah.
Sorry. So yeah, I studied maths and physics. Of course, I had physics to help with the space side of things. But with maths, it's been a key skill with problem solving. It doesn't always have to be algorithms that you're solving. It could be day-to-day tasks. So that is a core skill that is important for the space industry.
And a brief one for me, yeah, we are orbital dynamicists, tend to be astrophysicists or mathematicians. I don't know exactly their disciplines of maths, but they're essentially there to try and work out where the orbits are going to go and to apply various different ways of reducing the error in that to enable us to do collision avoidance. So we do use it. Whether or not it's their main discipline, I don't know.
Well, I just finished by saying I suck at math, so don't try. For the others, it's fine.
Have any of you ever considered ethical issues posed by advancements made in space, considering that more and more military applications are being used based on the developments we make in space, and how would you tackle those ethical issues?
All right, I didn't get the whole of the questions, sorry. I think that Earth observation should be a force for good, and that defence is, has its role to play in Earth observation, but it's enabling organisations to get governments, put the governments into account, as in, make sure that they don't go off the rails. We're seeing that right now. Obviously, everybody knows what's happening in Ukraine, and Earth observation has got a part to play in helping out where there might be or might not be, I don't want to be controversial, war crimes. You can do that by also going back in the past, probably, if you've got mass graves that are being built when there's genocides. So if you're thinking the last war in Europe that we had in Yugoslavia and all that, and had we had satellites then up there, we must have had, you would be able to detect through optical SAR where these mass graves would be dug. So there's definitely a role to play to keep people in account. I don't want to raise our flag too much, but we are trying to help in our own way, making our platform available for those that've got data to give us, to make it available to NGOs and so on, to keep people, you know, in check. Now, what are the governments going to do about it? I don't know. I can't answer that really.
Thank you, Andrew.
My pleasure.
Guillaume?
Yeah. Yeah, I can say a few things. So we created a company in space. We are based in the International Space University in Strasbourg, in France. And I did the master 10 years ago, and one of the objectives of ISU is to promote peaceful usage of, right, international for benefit of mankind. So of course, when you see militarization, you might say, oof, that's not nice. No, of course. You know, I think nobody likes that. But at the same time, space has become so critical for societies. The infrastructures that space is providing, whether it is for telecommunication or localization or climate change or monitoring of all kind of stuff, we totally depend on it. You know, now if, for example, I don't know, someone disabled a GPS system, it's pretty bad. You know, and you can argue that it's not nice to have military stuff in space, but at the same time, it's one of critical assets. You have police, you have navy, you have aircraft, which are kind of protecting the assets we rely on, right? So I think it makes sense when I look at globally the evolution. It makes sense that we see also some kind of force in space. Now I hope it stays as inspection and defense, and we'll see what happens, of course.
Thank you, Guillaume. We are now out of time. What I would suggest you do is join us at the reception at the end. You have been listening to Andrew Fournet, Zaina Rahman, Jacob Geer, and Guillaume Tanier. Please give them a round of applause. So find us, ask your questions. We're here to be, that's what we're here for. Thank you.
Thank you very much.
grab yourself a seat. Okay. Please take a seat and we'll start the awards ceremony before you get to the reception. Welcome to the UKSEDS Annual Awards Ceremony. Yeah. Yeah.
Sorry, you go. We haven't practiced. We practice. This is all part of the plan.
It's all heavily rehearsed.
Every year we give a couple of awards for some outstanding performers by both students and branches across the UK space sector and who are particularly related to the UKSEDS. Now, Ken Gordon has been kind enough to help us present it this year and to hand them out to the students who deserve all these awards. So I'll pass it back to Ken.
Big fan of the one person that clapped there. Yes, thank you so much. Yeah, this is a real treat for me. It's been a super day here. I've enjoyed talking to so many different people, all your aspirations, your dreams and your ideas, and it's really been great. I'm hoping I get to come back again, but only if I behave. So, the first award is for the Diversity and Inclusion Champion of the Year. Yes. Keep that going, yeah. This person ran the Aspiring Astronaut Grant, is Diversity Representative and Competitions, helped create the Orbex Gender Diversity Grant, and is an avid volunteer as part of the diversity team in UKSEDS. Do you know who it is? I know who it is. It's Anna Feldman!
She's not with us today, she's online.
Not with us today.
Thank you,
Not
Anna.
Thank you, Anna. We'll keep that for later. Okay, the next award, I love doing things on phones, is for Outreach Ambassador of the Year. This person runs the Major Tim Space Young Ambassador Program, has had lots of engagement with events for kids and young people, and started the Lockdown Star Striking Fact Series. Do you know who it is? It's Amanda Jane Piper!
I think Amanda's not here either. Uh-oh.
That's fine, we'll keep that for later. The next award. Oops.
She may have rushed to celebrate. She may have gone to get drinks.
She might have gone to get drinks, so we'll give her the prize later. The next award is for Branch of the Year. Whoa. Who wants to win this award? There's a lot at stake here. 150 members from a wide range of courses taking part in rover, rocket, rover and satellite competitions, both nationally and internationally, building a hybrid rocket test stand, and now a hybrid motor. They also build links with local schools, promoting STEM and diversity, and started Crantalks, space-based topics to improve public speaking skills. It is, of course, CranSed! Is CranSeds in the building?
They definitely are. They need to come
yes,
get their
at last! Yay! I'm so happy I can give this to someone. Wow, can we top that? Yes, we can. Next award is Most Improved Branch of the Year. What does that mean? Well, this branch, how bad were they? Anyway, this branch has got involved with Fuse, Google DevFest, NSSC 2022, did lots of outreach with local schools, hosted several social events, including a winter ball. Do you know who won that one? it's KCL. No one from KCL. Wait a minute, where are we?
They're definitely in the building. They're 100% in the building.
Okay, so this will be presented at another time. Okay. Right, my final awards presentation of this session, but not the final, is Student of the Year. Who would win? Who would win Student of the Year? Well, the person that wins Student of the Year is the KCL External Vice Chair. That narrows it down. In UKSEDS ran the Student Space Symposium, Hackathon, and helped organise NSSC. Took part in outreach workshops as an SGAC Open Cosmos Ambassador. And finally, satellite engineer, in brackets, hoping to launch a nanosatellite in 2023, analog astronaut. It is Joshua Bernard Cooper! And a gift, look. I've never seen a tardigrade, but God, they're huge.
They're very resilient, so they're fine with that, I promise.
Over to you.
Thank you to the OU for providing the tardigrade as well. Their mascot, and it's incredible, and we love it. And you are now the proud owner of a tardigrade. Yes? You may keep it. Right, we have 2 more awards. These are a little bit more internal to UKSEDS, but they are to people who are very deserving of them. One of them is specifically for phenomenal contributions throughout their lifetime within UKSEDS. I hope their lifetime lasts longer than that. They've been involved in UKSEDS in every aspect in one way or another for the last almost 4 years. They've single-handedly ensured UKSEDS systems have been running for plenty of occasions and events, including this one. I think everyone within UKSEDS already knows who they are. They've created a platform completely bespoke for last year's conference where we had 1,600 people. So without further ado, I think, Aaron Riedman, where are you? You need to come to the front. There he is. Would you like to say a couple words?
Speech? Wow, okay. This is so unexpected.
Make it quick. Everyone wants drinks.
It has been a pleasure to work with UKSEDS with these great people out the front here for the last 4 years. It's not just almost 4, it's 4. It's my 4th NSSC. Absolute pleasure. It's always a pleasure to work with these people. And I hope to continue doing great things with them, even if it won't be in UKSEDS, it'll be in other places. But these people are the people who deserve it, not so much me.
And the last award, but definitely not the least. This one goes to someone who has built a strong team and encouraged many others between the team to become leaders. They've improved our relationships with our external companies and other external organizations and people. They've helped us reach over 1 million interactions on Twitter organically, which to some people may not make sense, but to marketing people it does. This is for the UKSEDS Volunteer of the Year, and this goes to Mary Walker. And I really don't want to keep everyone any longer before going to drinks, because I know everyone wants a drink. So the last thing I want to say is a huge, huge thank you to every single UKSEDS volunteer who has helped set this up today, and to KCL Space for having us. We'll see you back tomorrow at the same time. Actually, a little bit later, so you can have a drink tonight and rest in the morning. But thank you to Ken as well for supporting today throughout the whole day. The space data was incredible. The awards were incredible. Thank you all. Over to wine and beer. And non-alcoholic beverages, of course. Yes, please do not take any drinks into the main foyer. If you see black on the floor, you are in the wrong area. Go back. Basically.